last time, I talk always to him. He was saying that, hey, I'm going away. And he apologized to everybody, hey, guys, whatever I told. So sorry for it and all this. I said, don't do it. You'll be okay. You'll be okay.
Hello. Good morning, Jagabandhu. Jagabandhu, can you hear us?
Yeah, good morning.
Good morning. So Professor Panda is there from North Georgia University.
Hey Jagabandhu, hi.
Hello.
Good morning.
Good morning.
So you are now in department?
Yes, sir.
Okay. Good. Because today is a Saturday. That's what. So we thought of to complete within 2 days, but we got so many 70 presentations. So that's the reason it was very difficult to conduct all the things within 2 days. So this today we'll have only half day. So by 1 p.m. We can finish it. That is what our target. Other things are fine, no, Jagabandhu?
Yes, sir.
Oh.
Jagabandhu, since when you are there? Like when you joined?
I'm here. I joined here in 2012.
Very recently,
No, 2012. 2000.
Oh, 2012, not recently. It's almost still 12 years. Huh? But you look like too young. Huh? I thought you just graduated with your PhD.
No, I completed my PhD in 2012. And I got my degree in 2013. But
Now it's a compliment. You look too young, like a kid. Huh?
sometimes it goes against me.
Against you. Your kid is there behind you. Now we can say you are old.
Yes, sir. Start it. Let us not delay.
Yes, sir.
So second presenters are there?
Yes, sir. Second, third, fourth are there.
Okay, let's start it.
A very good morning to all the presenters and participants. I am Arpita Das, Research Scholar, IIT Guwahati. Welcome you all to the final day of RCRM 2024. Hope you all had your breakfast and are ready for the upcoming presentations. Let's begin our session on the theme River Corridor Issues and Challenges. These presentations are categorized into two categories, 10 minutes and 5 minutes. In the 10-minute category, presenters will have 8 minutes for their presentation and an additional 2 minutes for discussion. For the 5-minute category, presenters will have 4 minutes for their presentation and 1 minute for discussion. Best paper will be awarded for each session evaluated based on 3 criteria: content, presentation skill, and subject matter. I kindly request all the participants to follow to the specified time limit during their presentations. Let's begin with our today's first session. I welcome Professor Sudhanshu Panda sir, Professor, University of North Georgia, a session chair, and Dr. Jagabandhu Dikshit, Associate Professor, Shiv Nadar University, Delhi NCR, a session co-chair. Let me introduce our session chair and co-chair. Professor Sudhanshu Panda sir
Hi guys.
is an expert in soil and water engineering, precision agriculture and geospatial technology. He currently serves as a professor of GIS and environmental science at the University of North Georgia. With a PhD in engineering, MS in environmental remote sensing and BS in agriculture engineering, Professor Panda has a unique career spanning field engineering in India, water resource engineering in Thailand and academic research in US. His extensive expertise include teaching geospatial technology, environmental science, information technology, and engineering courses. Professor Panda is a prolific modeler, software developer, and expert in sustainable water resource management. He has successfully secured grants from various funding sources, including federal, regional, local, university, and private entities, and has contributed and published to numerous peer-reviewed journals, conferences, and book chapters. Teaching is his greatest passion, and he is a dedicated researcher with a focus on environmental sustainability. Then coming to our session co-chair, Dr. Jagabandhu Dikshit is serving as an associate professor at Department of Civil Engineering, School of Engineering, Shiv Nadar University, Delhi NCR. He earned his PhD from the Indian Institute of Technology, Guwahati, and has authored various journals, books, and book chapters. Additionally, he has also received various sponsored research projects and consultancies focusing on multi-hazard assessment and structural design review. His primary areas of expertise and interest includes disaster risk reduction, earthquake engineering, and geotechnical engineering. So, before we begin our session, I would like to confirm from the session chair and co-chair if they have received the evaluation sheets.
We do. I do. So, Jagandu,
Yes,
did you?
I have received that.
Yes.
I have received that evaluation sheet.
Thank
Just
you.
a minor correction. My PhD is from IIT Bombay.
Okay, okay.
Yeah.
Oh, sorry, sir. Sorry, sir.
MTech
I
from
am
IIT.
from IIT Bombay.
Yeah, MTech from IIT.
Oh, nice.
Sorry, sir. I would request our first participant, Mr. G. Praveen Kumar, to present. Praveen Kumar, are you available?
I don't think so. Praveen, are you there? We will leave him and go for the next one.
Okay. Our next participant is Harshvardhan Solanki. Harshvardhan, you there?
Hello.
Yeah, Harshvardhan, can you
Yes,
share your presentation and go? And remember that Arpita will be the stickler to the time for you guys. She will just 8 minutes, she will just shout at you. You need to take another 2 minutes to finish. So we'll stick to like how he explains, okay? Go for it.
Yes, sir. Is the screen visible now?
Make it full screen, please.
Okay. Shall I start, sir?
Yes, please do. Yeah.
A very good morning, everyone present here. I hope you all are doing well. My name is Harshvardhan Solanki, a research scholar in the Department of Civil Engineering at IIT under the guidance of Dr. Priya.
Speak loudly, I think.
Okay, sir.
Can we manage
After I have a bad throat back. Okay. It's a pleasure to be here today. So I'll be presenting today our research on the topic of quantifying Budico-based water balance changes in tropical river basins. Did you know that tropical river basins account for a significant portion of world's freshwater biodiversity and are under unprecedented pressure because of the human activities as well as the climate change? So climate and human activities can significantly influence stream flow. For example, climate does alter the precipitation patterns as well as temperature rise, extreme events, and increase in temperature. Whereas the human activities impacts goes for urbanization, agriculture activities, deforestation, and which thereby have a combined consequences due to the on the impact of increased variability in the stream flow, altered timings in the peak flow, as well as erosion and sedimentation. So climate change induced changes are thus very important for the change can lead to shift in precipitation patterns, increased frequency of extreme weather events, as well as these factors collectively impact the stream flow patterns. So what was the motivation behind the study was the Sabarmati and Mahi basin largely experience semi-arid to subhumid climates. The semi-arid regions are inherently prone to water scarce condition due to moisture deficit and excessive heat stress. And moreover, the climate and anthropogenic activities exacerbate water scarcity. So the objectives of my study are as follows: investigating the presence of sudden shifts in the stream flow time series for two west-flowing river basins, applying the Budico hypothesis and climate elasticity approach to sorry to identify gradual changes in the stream flow. So this is my study area. Basically, we have taken two tropical river basins, Mahi and Sabarmati, and the average annual rainfall for Mahi basin is around 900 mm, whereas for Sabarmati basin goes for 690 mm. The materials and the methods used in the study are as the Petit test. The Petit test is a non-parametrical approach. We can say that it is used to detect the change point in a time series of data, indicating where a significant shift, maybe a mean or variance has been occurred or not. Secondly, the Budico curve is used, which is nothing but a theoretical framework introduced by Mikhail Budico, which is a Soviet climatologist in the 20th century. It represents the relationship between the climate's aridity index, that is the ratio of potential evapotranspiration to the precipitation, and the evaporation ratio, also known as dryness index and evaporative index. So Budigo framework actually it offers a conceptual model for understanding the balance between water input and the output of a catchment. However, quantifying its application is dynamically changing environment of tropical river basins presents a unique challenge. So the concept behind this is that it is used to understand how changes in climate, particularly change in temperature and precipitation, might impact water availability in different regions. So dryness index, as I already mentioned, is the primary it is used to describe the aridity of the catchment, whether it is whether it is humid, arid, or semi-arid. And it is a dimensionless number, the dryness index, which is potential evaporation to the precipitation. And if the value is of dryness index is greater than 1, so which indicates that the demand of water through evaporation and transpiration exceeds the available water through precipitation, which thus characterize arid or dry conditions of that region. Whereas the evaporative index, also known as actual evapotranspiration ratio, is calculated as AET by P, which is also a measure. Also, it represents that the close to high value suggests that most of the precipitation is lost through evapotranspiration. Now, coming to the next methodology, that is climate elasticity. So, the climate elasticity method is a quantitative approach which is used to assess the sensitivity of a water resource system such as stream flow or groundwater recharge to the change in climate variables, for example, precipitation and temperature. And it uses climate elasticity coefficient. For example, we have here in this equation epsilon p and epsilon e naught. So these coefficients are dimensionless numbers that quantify the percentage change in a hydrological variable like stream flow. So let's move on to the data sources which are required for the study. For my study are daily graded rainfall data which we got from IMD, and daily stream flow data, and monthly potential evapotranspiration data. So on the right side we have the methodology flowchart which depicts that we have used stream flow, rainfall, and PET to do the Budigo analysis to explore climate characteristics and attribution of stream flow changes due to climatic and as well as the anthropogenic changes. Climate elasticity analysis is used to identify the influence of climatic parameters on the stream flow changes next, and thus a relative contribution of climate as well as anthropogenic contribution is taken on the stream flow changes. So these are my results for the change point analysis. First, as we have taken the change point to measure the before and after analysis for Budigo curve, and we have taken in total number of 12 subcatchments, including Mataji, Rangeli, Padiyatipudi, Dharyawad, Kanpur, Chakalia, Derol, Jotasan, Heda, Ratanpur, Heroj, and Botha. And same goes for this. We have Budigo. We have mentioned we have done Budigo analysis for the Mahi Basin, and it is before change point analysis and after change point analysis which shows the behavior of the area. Same goes for Sabarmati. The notable point that we have is after after the Budigo analysis we have gone for the climate elasticity method. So here significant changes in precipitation and stream flow has been observed. Like the more contribution is from the human influence activities after the analysis that we have got for the Mahi Basin as well as the Sabarmati Basin. And so the conclusions we draw from the study are that the change point analysis shows the presence of change point and in approx 1999, and with major stations like Mataji and Dharyawad shows a major rise in runoff, while Chakalia and Khanpur shows a decline in the stream flow. From the Budigo analysis we have done, a notable shift towards drier and warmer meteorological condition is observed in both the basin except for Rangeli after the change point. So this dry and warm condition exhibits that there is a water scarcity and states that there is a heat stress in the region. The climate elasticity analysis showed that human influence significantly affect runoff changes in Mahi and Sabarmati basin. and most of the station in my basin shows an increase in runoff, while the runoff changes in Sabarmati are relatively not considerable. Also rainfall changes are considerable compared to potential evapotranspiration changes. Thank you, sir.
Okay, thank you. Harshavardhan?
Thank you, Harshavardhan. Now, floor is open for questions from the online folks and from offline folks. Anybody have any questions for Harshavardhan? None? None online?
So I have one question.
Yeah, please. Yeah.
So the question is, when you talk about that, particularly in your study, that the water balance changes and the impact of climate change, etc. How did you take care of the geomorphic parameters or the geomorphology in the broad sense?
Sir, geomorphology, as LULC has been considered for that, the impact of how the
Yes, ma'am. Actually, due to some technical.
uh, hello, sir, am I audible?
Yeah, we can hear you.
Okay.
Yes, sir. Sir, geomorphology is considered because of the before and after we have done also like the LULC changes, like how the human activities impacted like the construction or the gray concrete has been used.
Anything related to your topography, slope? Hello, am I audible?
Yes, sir, yes.
Yes, Jagavandhu, you are. Yeah.
Yeah. Did you consider the slope, topography, the geomorphic conditions, geomorphic indices, to be very precise? Did you consider them in your studies? In addition to your land use, land cover, or
Yes, sir.
the.
No, sir, at this stage we have not considered it yet.
So when you have different topographic conditions, the DEM profile
Yes,
that
sir.
you might be having,
Yes, sir.
the digital elevation model that you
Digital model.
used, so that is again going to have the impact of geomorphology in relation to inundation,
Yes, sir.
every
Inundation pattern.
aspect. So, okay.
Harshavardhan, that's a good suggestion from Dr. Like Dr. Dikshit. So you need to really include that one in your next research. Okay, continue working on putting into those geomorphologic characteristics into your analysis. And I have a quick question.
Thank
Uh,
you. Yes, sir.
have you the IMD, does it provide minute by minute data or average daily data? Can we get
Daily data.
daily data? Can we not get 15 minutes data or 10 minutes data from them?
No, sir.
Do they have storm events data to create our PIDF curve? Have you tried?
Sir, actually, I've been working on data from ERA5 and other apps. We can have the data downloaded from the Google Earth engine.
Oh, okay. No, why I'm asking, because PIDF is very essential for this kind of studies. And we need to learn how to get data from there and develop a PIDF. And you, instead of using P, we will be using the PIDF value 50 years, 24 hours, or 100 years, 24 hours, or something in our study. So nowadays, climate change is impacting rainfall intensity heavily. So you need to think about that and take into consideration. Okay. Thank you. Okay. And you may stop sharing. We'll go for the next presentation.
Sir, our first presenter Praveen Kumar has joined. So can he present?
Yes, he can.
G. Praveen Kumar.
Praveen, if you are there and ready, share your screen and start presenting. Praveen, are you there? Is your,
Yes, sir. He just called now.
okay. Maybe we'll go for the third one and we'll ask him to present after this. Okay.
Okay, sir.
Yeah.
Our third presenter, Arpit Tiwari.
Arpit, are you there? You can start sharing your screen and start presenting full screen.
You are given 8 minutes to present.
Yeah, go ahead. Go ahead.
Good morning, everyone. Myself, Arpit Tiwari. I'm tech student from IIT Indore under the guidance of Priyank J. Sharma sir. I will be presenting my work on analyzing the flashiness characteristics of tropical rivers with my colleague Suyash Shukla. So the changes over the rainfall patterns due to the climate change have made our streams more flashy in nature. So here are the some few incidents, flash flood incidents for your reference, like Narmada and Surat flood 2006 and 2022. Our objective to develop the new indices to characterize the stream flashiness, then evaluate their temporal changes and assess their relationship with the catchment area and peak flood magnitudes. So this map shows our study area. We have taken the 12 stream gauge stations data from the Narmada River and 6 from the Tapi River. So here it is our methodology. We have collected the data, derived the flashiness indices, then identify their temporal changes, and we have done the trend analysis in these parameters by using the modified Mann-Kendall test. Then we have explored the temporal dependency of the stream's flashiness through the Spearman rank correlation. Then we have established a relationship with these indices of catchment area and peak floods. So here it is the list of indices which we have used in our analysis. All the 6 are not used, but the third one is newly introduced by us. It is SFI, Stream Flashiness Index. You can say it may be a little bit similar with the RBI, but there is a slight difference. Like RBI takes all the changes in the daily stream flow, but stream flow flashiness takes account only for the maximum changes in the stream flow with respect to the annual maximum flood. These are the list of indices. So then we have calculated these all 6 parameters for 18 stations for the data from 1978 to 2018. So here I have shown the I have shown the variations only from the Gidhade station, which is more prominent to the significantly changes by the climate change. So you can see that there are increase in along all the 4 parameters except the annual maximum series. So Gidhade is out of 18, Gidhade is the most emerged as the most impacted station by the climate change and anthropogenic activities. As you can see, I have mentioned the Surat have flash flood in 2006. So the red dot in the annual maximum series shows the same. Also, we have done these studies along with all the 18 stations, and we have tested these stations with the modified Mann-Kendall. So as the Z value, based on the Z value, we have classified them as in that stations there is a significant decrease, increase, or no trend. So as you can see, I have told you you can see that Gidhade station have more significant increasing trend in all the parameters, and along with the Tapi river, you can see the intermittency index is increasing with the years. So these are the trends. This table shows the trend is in these parameters. Now I will invite my colleague Suyash to discuss more.
So good morning everyone present there. I'll be continuing the presentation from here. So after that, what we did was we calculated how well RBI is connected to other parameters using this Spearman's rank correlation, which is a non-parametric test. And what the results we achieved is that the strongest correlation was with CV, and the strongest negative correlation was found with annual maximum series. Also, we saw that flashiness of a stream decreases with increase in catchment size and peak flood magnitude. Next. So these are the heat maps of RBI and CV over all the stations of Narmada and Tapi from 1978 up till 2020. So the major things that we can see here is that in the mainstream Narmada, there has been the RBI has been more or less uniform only. Very little variations can be observed, but in the tributaries we can see there have been major changes where there are dark blue boxes, but the same cannot be said about Tapi. also, since CB had a good correlation with the RBI, we can see that almost it has a similar trend. Also, one major thing here is that in the Kogaon, we can see that there has been a very dark blue blocks, which shows that a good value of a high value of RBI, and this was because there was there was flash flood magnitudes of 300 cumex, followed by followed in a very dry season, and then again a very low flow afterwards. Next. Also, this SFI that has been introduced by us shows that the stream is very flashy in nature, both the streams. Also, as Arpit already told, that the intermittency index, we can see that in the mainstream Narmada River, the intermittency index is almost close to zero only. And in the tributaries of Narmada, intermittency index is increasing by the day. And the intermittency index overall in the Tapi basin is increasing day by day, which is of great concern. Next. So we tried to establish a relationship of FFMI with catchment area and annual maximum series. So at first we used the data for both the stations combined, and we couldn't draw any conclusive results. But after that, when we did the same for the Tapi basin alone, we found a good correlation of FFMI with area and annual maximum flood. The reason for the same could be because FFMI is highly influenced by low magnitude floods.
Shreyas, you have 2 minutes left.
Okay. And the reason for that is because log scale distributes smaller values more finely, and we have used log scale in FFMI. Next. So the conclusions are, the results indicate that RBI exhibits a significant positive correlation with CV, SFI, II, and FFMI, while a negative correlation with peak floods and catchment area. Also, the modified Mann-Kendall test findings reveal a notable decline in RBI, CB, SFI, and peak floods at most stations, which we saw at the Narmada stations. But the same cannot be said about the Tapi stations, which indicates us. Also, we can see that for the average FFMI for Narmada and Tapi is 0.336 and 0.34, while for the tributaries it is much higher, that is 0.364 and 0.414. Also, as already discussed, that the Tapi River has been drying by the end of every year, and except at Ukai, the intermittency index has been increasing very significantly. The average FFMI for all the rivers is 0.244, while for Tapi and Narmada is very high, which shows that both the streams are very flashy in nature. Also, as discussed by my colleague Arpit, the Gidhade station was seen to be most susceptible to the climate change. Thank you.
Okay, nice, both of you, and Arpit and
Thank you, sir.
what is his last other? Say Suyas. Yeah, Suyas. Yeah, good job. And now the floor is open for the online and offline questioning and any suggestion to both of them. Anybody from attendees? If not, Jagandhu will ask if he has any question. Offline, online, please.
So, Mr. Arpit and your colleague.
Yes,
So
sir.
in one of the slides, particularly slide 4, you have fitted a line. I'm not going slide by slide, just a question related to that.
Yes, sir.
So when we fit a line, we have some objective, right? So what is the objective here? You have some scatter points and you have fitted a line. Of course, you don't have R square or anything, and on one side you have SFI and the other side you have R square. No, sorry, the years.
Years.
So what is the objective of fitting that line on top of those points?
Sir, it shows the trends, how the parameters are changing over the years.
Okay. Yeah, nice.
So are you opening that slide? Or
Yeah,
or
yes,
just a
sir.
second?
Yeah, yes, sir. Yeah, I can.
Slide number 4, go there. Hit your space bar on the keyboard 6 times.
Yes, sir. This one.
Yes.
Yes. So what does it indicate? So when you have all these scatter points and the lines are just fitted, whether the fitting is correct or not, that is of course you have not mentioned here. But what exactly it's telling? Is there any story behind these lines, or it's just? And
It's
somehow
just
you have the outlier also in the red circle. So what are
it's
these?
you can say like it's the best fitted curve between these two parameters which are in the axes. So, sir, with this line, we can just predict that how the RBI is changing over the years, like intermittency index is increasing for the Gidhare station. So we can just, by seeing these graphs, we can conclude what is going with these
Okay,
stations
fine.
around over the years.
Thank you. So when you talk about all these indices, did you
Yes, sir.
include any of the uncertainties that you might be having?
No, sir, we haven't done it.
Are there any factors which are going to create some kind of like you have some outliers here in annual maximum series?
Yes, sir.
So like that, is there any reason behind this?
Sir,
Or any
these are sir flood events which have occurred in this basin.
Okay.
Yes, sir.
Thank you.
Arpita, I had the exactly same question on slide number 4. Stay there.
Oh,
So
okay.
you
Okay,
actually didn't explain too well to Dikit sir. So you told that the red circle is the flashiest point, maximum flooding happens or flash flood happened at that time. And
yes, sir. 2006.
Right, and you are explaining that climate change may have an impact, but you can see
Yes,
that
sir.
in 1975 you have even 2 flash floods. So that means the climate change impact is really not there. We should conclude.
Sir, actually, sir, these points are not showing the flash floods. These are the annual maximum series points. So out of these 3, the only this red circle was the flash flood.
Okay.
So we are predicting like that it is due to the climate change that the basin is showing flashy nature.
Okay, but
The
you
earlier
need
2 events was not necessarily the flash flood, sir.
not necessarily, because you can check that you have the amount of floods is much below level in most of the cases.
Yes, sir.
Suddenly you have 2
Yes,
points really spiking up. That should be flashy. Something happened on that year, 1977 or 78. Something happened.
Yes, sir.
Yeah. So you need to really give an argument for it and explain it well. And my
Okay,
other
sure, sir.
other question is in layman's language. Can you guys just explain the heat map? I didn't get it from the heat
Yeah.
map, the color things.
Yes.
So layman's language.
Sure, sir.
Yeah.
Yes, sir. So yes.
The heat map is just trying to tell us that what are the changes that have been occurred in both the Narmada and Tapi basins.
Okay.
So the first 12 stations are of Narmada, and then the 6 stations followed by are of Tapi.
Right.
And what we wanted to tell you is that in the Narmada basin, in the mainstream Narmada river, that is not on the tributaries, there have not been much variations as compared to the tributaries, where we can see that the stream is more flashy if we use the Richard Baker index and also the SFIA. Also, we wanted to tell you that the intermittency in the tributaries has been increasing by the day, and in whole of the Tapi, the intermittency is increasing, whether it is the mainstream Tapi or the tributaries of Tapi.
Now, if I interject, if one stream has a lot of color variation, that means it is flashy.
Yes.
If it has one single color throughout the year from 1978 to 2000, then it is just normal flow, not flashy. Is that the layman's way to explain or not?
Yes, sir. But what we have done here is that this dark boxes, they show the values of the RBI, SFI,
The coefficient. Yeah, the index coefficient.
Yes,
Yeah.
Yes, sir. So the dark boxes means the values of higher magnitude, and wherever the value is of higher magnitude, it shows that the stream has been flashy on that particular year, or the trend has been like that.
Right. Okay.
Yes, sir.
And by the way, very nice work. That's the reason too many questions, and so you should be working on it and
Thank
to
you,
explain
sir.
well. Yeah.
Thank you so much, sir.
Thank you,
Thank you
guys.
so much, sir.
Thank you, guys.
Okay.
Thank you, sir.
Yeah. Now to Arpita, please.
Thank you very much. Our next participant, Subhalakshmi M. Lakshmi?
Yes, ma'am.
Yeah, you can share your screen.
Praveen is not there yet.
Praveen? Oh,
Okay, we'll go after Suvalakshmi. Yeah. Suvalakshmi, please share your screen and make it full screen. Yeah.
Okay.
And go ahead.
Is my screen visible?
Yes, it is visible and go present.
Thank
Yeah.
you. Okay. Good morning, one and all present here. I am Subbulakshmi, research scholar from SRM Institute of Science and Technology, Katangulattur, Chennai. And my guide is Dr. Sachikanda, Associate Professor. Our topic is mapping climate-induced flood risk, a case study from Kadalur district, Tamil Nadu. Introduction. Floods are an extremely destructive natural disaster, profoundly impact nearly 21 million individuals worldwide as reported by the World Resource Institute. This could be projected to 54 million by 2030 due to influence of climate change and diverse socio-economic advancements. Regarding to flood-related consequences, India ranks second globally in terms of damages and holds fifth places in flood-related death. Flood influence various sustainable development goals, mostly importantly, sustainable goal 1, 11, 13 are influenced by flood. Flood risk mapping map plays a crucial role in flood mitigation as it helps to identify the areas which is most susceptible to flooding, allowing for proactive and anticipatory response rather than reactive ones. By identifying the most vulnerable locations, flood risk mapping provides sufficient time for people to prepare and respond to flooding. There are various methods available to prepare flood risk map. Here we have used analytical AHP method, that is analytical hierarchical process method to produce a flood risk map, which is produce accurate and reliable flood risk maps by efficiently integrating multiple influencing factors like dam, slope, distance from river, etc. This is our study area, Kadalur district, which is located in Tamil Nadu state. It is a coastal, it is nearer to coastal region, Bay of Bengal, nearer to. This map is taken from NDMA, National Disaster Management Authority. In 2020, flood inundation area was represented as red points. Um, Kadalur district was frequently affected by flood in the recent years due to the climate change. We have done LULC change analysis and rainfall trend analysis. From that, we identify that trend analysis, rainfall trend is the major reason for this flood. That's why we have used climatic data for producing flood risk map in these studies. So this is our methodology adopted for this study. So we have used three types of data: digital elevation model data from SRTM DEM. We have used Landsat images. 2020 was used for preparing LULC map, and CM-IP6 GCM model data were used for the precipitation map. Here we have taken 2020 to 2050, 30 years average annual rainfall was taken for the analysis. From the DEM data, we have prepared a distance from river, a topographic wetness index map, elevation map, slope map, drainage density map, and stream power index map. From the Landsat image, using ERDA's software, supervised classification, we have prepared a LULC map. Here we have used 7 classes. After preparing the thematics map, we have reclassified for the AHP analysis. Each map was classified into 5 categories. That is very low, low, moderate, high, and very high risk areas. After that, we have prepared a pairwise matrix. From that, weights were calculated. Then we go for consistency check. If the consistency check was okay, then we go for weighted overlay analysis. Otherwise, we again go for pairwise matrix. From the weighted overlay analysis in GIS platform, we prepared a flood risk map. So these are the flood influencing factors mapped. DEM, slope. So from the DEM, we have seen that the upper portion of the area has a high elevation and the coastal region has low elevation. This is a slope. This is the NLC place. This is the river. This is a reservoir, and this is one lake. This is the drainage density map. It shows where the flow is accumulated. This is the LULC map prepared. The red shows the settlement area. This is the NLC area. This is Kallakurichi district, Kallakurichi town, and this is Chidambaram temple. These are highways. This is a reservoir. This is one lake. So there's a mangrove forest in the backwater of the This is Vellar River, which is mainly flowing in the Kadalur district. And this is Tenpanayar River, and this is Kolledam River. These are the major 3 rivers in the district. So the stream order map in the Kadalur district has a maximum 5th order stream. This is written from river map using Euclidean distance tool. We have prepared this. Stream power index map and topographic index map clearly shows where the flood water is accumulated. So these are a precipitation map for future 2050. We have taken 2020 to 2050 daily rainfall data. We from the Mishra data, which is bias corrected data. Using IDPW, we have created this precipitation map. So pairwise matrix, from the pairwise matrix, the precipitation has highest weightage, nearly 20%, and the distance from river has the second weightage, 17.6, and the distance, drainage density has third weightages. It is a tail end part, so that's why elevation and slope has a minimum weightages. From the consistency check, it is correct. Okay, that's why we have fixed with this.
Subbalakshmi, you have 2 minutes left.
Okay, ma'am. Okay, ma'am. So from that weightages, we did the weighted overlay analysis in the GIS platform, and we have created this flood risk map. This map was almost matched with the 2020 flood inundation areas, and some more areas also covered. So these areas are red are a very high risk area, and blue colors are high risk area, and this green colors shows moderate risk areas. This table shows how much the area or percentage of area are covered by the under each classes. Nearly 18.4 and 16.4% of areas comes under high risk areas in both scenarios, SSB 245 and SSB 585. And moderate risk areas also very high, almost 50% of areas comes under moderate risk areas. These areas also need to be considered for flood. Conclusion, in recent year, Kadalur district has faced recurring flood incident, underscoring pressing need to address these growing challenges. The studies aim to proactively address future flood risk, developing by a flood map using projected climate data. This, the identification of high-risk areas provides the opportunity to enhance infrastructure and establish effective early warning system. Thank you.
Subbalakshmi, good work and good presentation. Anyone from online or offline audience have any question for Subbalakshmi? Please.
Good morning. Hello.
Yeah, go ahead.
Hello.
Yeah, ask. Yeah.
Good morning. Thank you, madam, for the presentation. I have just one question. In your digital elevation map, the lower value is in negative, and I think it's minus 250 something. So could you just explain why that is the case?
The end part is in the sea area. If you see the
Is it? But I don't think SRTM gives values below sea level. So if you could kindly
our
check.
study area is on this portion is in the sea area. That's why.
No, go to the DEM map. Go to the DEM map.
So not all the points, only 2 or 3 points in this area only has minus 255. Other than that, all have positive areas.
No, you are right. Actually, in the middle there is a lake. There is a lake. Maybe it is dried up when the DEM is created. So it is below mean sea level. So it's in the middle.
Yes, no.
It's in the middle.
This is NLC, actually, Naval Lignite Corporation mining, sir.
Yeah, mining. Yeah. So that might be a mining area. So. And that is correct.
Sir, I just felt it's 250 meters below sea level is allowed.
No, it's a mining. It's a deep mine, so it should be. So it is correct. So, next question, please. Anybody? Jagabandhu, you have any question?
Yes, the question is again on the same map, the study area map,
Right.
particularly with the inundation map is for 2020.
Right.
So is it right to say that it is because of the climate change?
Sir, we have done LUNC change and trend analysis for rainfall. It shows an increasing trend. So that's why we identified climate change is the major reason. In the newspaper also we have read that the 2015 flood and 20 floods are 100-year recurring floods due to climate change.
Okay.
From
Now the
studies
other
we
one.
have,
Okay.
Okay.
The other one, your study is based on ASP.
yes,
So
sir.
how did you consider the weightage factors?
From the study area knowledge and that pairwise matrix, sir. We check the consistency check. If the check was not correct, then we again go for the pairwise matrix and change the weightages, sir.
Perfect, perfect. Now coming to the same question, that ASP when you talk about, you have the expert judgments required, right?
Yes, sir. Yes, sir.
What did you do for this particular study area? Because the judgments could be for different basin, different topographical regions.
Actually,
something
it's
like
one
that.
of
For
the
that particular district you are working on, what did you do?
We met with the government officials while collecting data, sir. We discussed with the pairwise matrix with them also. And during conference in the Anand Sri Banduti campus, some experts in the Kadalur districts, we met and discussed, sir.
That is good.
Okay.
Yeah. And that is correct answer. And you need to add that one called Delphi method. So you need to research on Delphi process. So Delphi process
Okay,
is
sir.
DELPHI. And I have two questions.
Yes, sir.
I have two questions for you. One negative.
Okay.
You did not use the soil data, which is very important for flooding analysis. So you must use soil data to make sure that your study is correct. And number two is you have used the drainage density map. So drainage is a positive thing. If in a locality you have higher drainage density, means flooding will be much less. Water will pass through the drain. So you need to think that to give a positive value or negative value in your analysis. That way the entire study will be kind of close to perfect. But a good study.
Sir, we will consider, sir.
Yes.
Sir. Thank you, sir.
There you go.
Oh.
And
Thanks,
you,
sir.
yeah,
Yes, sir.
and you can unshare your screen, and we'll go for the next presentation. And over to Arpita.
Sir, can we call our first presenter, Praveen Kumar?
Is he there? If he's there, then we'll go for
Sir,
Praveen.
we can see his that he is online. Should we call once?
Praveen, are you there? Can you present? Go ahead and share your screen and present. We will deduct 3 marks from your score because you didn't come. I'm joking. I'm kidding. Go ahead, do the presentation. Share your PowerPoint and make it full screen. And go ahead. His audio is not working. And also make sure you unmute yourself. You are muted, seems like, so you unmute yourself.
He has unmuted himself, but his audio is not coming, sir.
Can you check your audio? We will go to the next presenter and you will come back again. So we'll deduct 1 more mark from your score. Just kidding. So check your audio and we'll come back. Audio working now or no?
No, sir.
Can you speak up? Let us listen. Are you speaking?
Yes, sir.
Now it is good.
Yeah, please share your screen. Make it a slideshow, full screen.
Yes, ma'am. Ma'am, is this visible?
No, you have to make it full screen. Click on the drinking glass. Just kidding. Again. On the
Sir, I made full screen.
No, it is not. Bottom right, click on again. It's not full screen. Bottom right, click on the glass icon.
Yes,
Yes.
yes
Click.
sir, I made.
Maybe your connection is slow, so it's taking time.
No, sir, he must have not shared his full screen.
Oh, okay. Okay, you need to share your full screen. Go to the share button and click on the two screens over there or one screen over there. It will be below the...
Sir, I have shared the same thing.
On share first. Like on share first, then click on the share icon again. On share it. Stop sharing. It should be in the top middle, the red color one. Yes, you good. Then click on the share button again. Click on the share button. And then click on the screen icon shows up, window shows up at the bottom. Praveen, you do good?
Yes, sir.
Okay.
Sir, now it's okay.
It should be. We have not seen it yet. Make full screen again. Let's see.
Yes, sir. Yes, sir, I have made full screen. Is this visible?
No. Okay, you go ahead. Just click on each screen and go. Go each slide you click on and go forward. We'll be okay.
Is this okay?
Start presenting.
Okay, good morning. Myself is Praveen Kumar. I am here to present my topic, ranking of CMIP6 GCMs over the Kali River Basin region of Karnataka State, India. I am from NIT Suratkal. My presentation following these contents, introduction, summary of literature review, study area, data products and methodology, results and discussion, summary and conclusion, and selected references. As we know, water is the basic...
your slide is not moving. Praveen, your slide is not moving.
You have to click on the second slide.
Ma'am, we are moving, ma'am.
Click on the second. Oh, do we have his presentation?
Yes, sir, we have.
Okay, can you unshare? We will share from here and you will talk about it. Unshare completely.
Okay, sir.
Stay put, we are sharing your presentation. Then we will,
Okay, sir.
you need to say, go forward, then we will go for the next slide.
Okay, sir.
Go ahead, talk about from the beginning.
Yes, sir. Respected chair and co-chair and participants, good morning, one and all. Myself G. Praveen Kumar from NIT Suratkal. Today I am here to present my topic, ranking of CMIP6 GCMs over the Kali River Basin region of Karnataka State, India. Next one. My presentation following contains like introduction, summary of literature review, study area, data products and methodology, results and discussion, summary and conclusions, and selected references. Next one. As we know, water is a vital resource for every human living organism, and water demand is increasing tremendously as population continues to grow. But recent studies saying that water scarcity increasing across the globe. So efficient and sustainable water management of water resources is crucial to preserving ecosystem and meeting the needs of the future generations. As we are talking about climate change, so GCMs are effective tools to project the future scenarios in future happenings. So GCMs are like assessment reports are there, AR1, AR2, AR5. So recent one is AR6 assessment report 6, that is CMIP6, coupled model intercomparison project phase 6. So these models are developing by different countries across the globe by different institutes. And if we go these models, every model have their own weaknesses and strength. So we need to rank them. So which model is better perform for our study area? We have to know that. And then these are the summary of the literature review. So these are the some others which have studied ranking regarding ranking. So the overall conclusion is this one. And this is the study area. So Kali River Basin, which is located in the 74 degrees 5 minutes east latitude latitudes, and it is flowing, it is joining in the Arabian Sea with the length of 184 kilometers, and its catchment area is 4,837 kilometers square. It experiences like 2,750 mm of annual average rainfall. So these are the data products I have used for this study. CMIB data and CMIP6 data. So 28 models I have considered from CMIP6, and we have ranked we have collected from 1951 to 2014 historical data. Next. This is the methodology of the study. So we have collected CMIP6 data, precipitation and maximum temperature, minimum temperature variables, and as the CMF6 providing 0.25 by 0.25 resolution precipitation and temperature, and IMD is 0.25 degrees of precipitation and 1 degree by 1 degree maximum and minimum temperature. So we have regraded by bilinear interpolation, and after that bias correction. So with bias correction we have used linear scaling method, and then we have performance indicators we have calculated. RMSC, KG, Klingupta efficiency and skill score and a coefficient of correlation. And after the performance indicators, we have performed normalization to bring that to common platform or common scale because of the variance in different ranges. So we have used here maximum linear normalization or linear normalization method, which considers like maximum of value of the column, and it divides with that remaining values. So after that normalization, we have done weighting method, which is critic method. So criteria importance through inter-criteria correlation method. After that, we have a ranking method we have used. So this is simple additive weight method or weighted sum method. It is also called as weighted sum method. So in this method, like after we get to the precision matrix, so after we have to apply each variable with weighting, and we have to multiply each variable variable into with that weightage method. And after that, we add and we have to add all those variables with and we get a performance score. So that the performance score, based on the performance score, we get ranking. So this is the simple additive weight method, as I mentioned, which is also called as summation method, and it does summation of the methods and values of each value. Next one. So these are the performance scores I have showed here, like RMS at each for every model and at each grid location. So RMSC for ABC or RMSC for precipitation, maximum temperature and minimum temperature. And DEF is for skill score of the precipitation and the maximum temperature and minimum temperature of every model at each grid level. And these are acceptable to be found. Next. These are the ranking of models at each grid. So grid-wise, at each grid, which model is performed better. We have analyzed this. So here see A, B, C is for rank 1 models. A is rank 1 model for precipitation. B is 1 model for maximum temperature. C is minimum temperature, rank 1 models for minimum temperature. And D, E, F are rank 2 models for precipitation, and maximum temperature and minimum temperature. And as we see here, like S3 is performed most of the grids for rank 1 for precipitation. And here EC F3 performs for most of the grids maximum temperature. And Thai EC is performed for all grids like for minimum temperature, rank 1. So for rank 2 models, grid, most of the grids EC F3 performed better, means rank 1, rank 2 this one. And for maximum temperature, for rank 2 models, NEST 3 and KSOTSM performed like rank most of the grids. And for minimum temperature, CMCC CM2 SR5 model for ranked at all grids as a rank 2 model. Next one. So when it comes to summary and conclusion, so we have used for ranking simple additive weight method with the linear one normalization method and the critical weight method. So rank 1 GCMs are like ECF3 and for maximum temperature ECF3 and ISM for minimum temperature for CMC data for rank 1 and rank 2. NEST3 and KSOTSM for precipitation and MPA ESM to LR and ECF3 for maximum temperature. And CMCC CM to SR5 for minimum temperature of the CM6 datasets. Next, these are the selected references. Thank you.
Okay, Praveen. So finally, it is over for you, and the floor is open for questions from our audience first. Anybody offline, online have any question or suggestion for Praveen? Please. You can speak up.
So, Mr. Praveen?
Yes, sir.
We can
So when you deal with so many models, different types of models, of course, under the umbrella of GCM,
Yes, sir.
then how do you take care of normalizing them? Of course, you are normalizing.
Yes.
But what are the challenges you are facing when you deal with so many models, which might be having different factors and different spatial resolutions of data? So how do you deal with them?
So like all these models available next GDDP, so all are same resolution 0.25 resolution.
Your answer was so brief and I couldn't listen to part of it.
Sir, these datasets I have collected from next GDDP. So all models have the same spatial resolution like 0.25 by 0.25 degrees.
Okay. So any uncertainty that you saw which is propagating all throughout this model tuning, model normalizing? Did you see any uncertainties that is getting accumulated over time?
No, sir, but by we directly bias corrected, and after that we have performed performance indicators. So which perform better, so we can to the models.
Okay. Okay. Thank you.
Praveen, I have a question on the similar line. What is the fun of using so many models if one model really ranked for precipitation number 1 and another model ranks for temperature as number 1? Why we need to use so many models? Just use one.
Because for a particular location, we can't use directly. We don't know which model performs better. So that's why after among the all models, which is performed to our locality. That is the
Yeah, I know that. That is the reason I'm asking. If one model works well for precipitation, one for temperature, one for minimum temperature, and one for something else, then how do we choose? That is the only model is the best one for combining all the parameters to make some decisions. What should I do? So what is your criteria to choose a unique model? That one is good for everything.
Sir, maybe not all models, because no model is unique for every place. So
True. No, I am talking about not place. I am talking about your variables we are using for analysis.
yes, sir. I have used like precipitation, minimum temperature, maximum temperature.
Okay.
So these are as historical data. So which models like performed with matched with our observed data. So
Okay.
that model we can use for future projections.
Okay. So that means independently you will use individual models for projecting future temperature
So
data.
after this ranking, which is performing better for my study,
Okay.
so I use for future works those models.
Okay, good job, and really think about it. Okay.
Okay, sir. Thanks.
Okay, and you are not sharing, so we are good. We'll move on to the next presentation. Back to Arpita.
Thank you. Our next presenter is Lima Hazarika. Ma'am, are you present?
Dr. Hazarika, are you there? Dr. Hazarika, are you there? Lima, are you there? Maybe not there. We are skipping, actually postponing this one maybe later time. So we are moving forward. And next one is Mrs. J. Uma Maheshwari. Maheshwari, if you are present, can you share your screen and full screen and start presenting, please? Uma Maheshwari, are you there?
She's here, sir.
She's here. Like offline?
No. She is present online.
Online?
Hey, sir. And
Uma, yeah, can you, Uma, can you share your full screen and start presenting?
okay.
Yeah, go ahead. Go ahead, please. Make it full screen, please. Oh, you are using a PDF file, seems like, huh? PDF, there should be some option for page, like view page.
I think it is Control L, I think.
Control L, can you use Control L then? Hit Control L.
This is not PDF. This is something else.
You can on-share, and then we will be sharing from our side, and you will say when you go to the next slide.
Okay.
Yeah, please on-share.
Okay, sir.
Please on-share.
Okay, sir.
Yeah, she is using Google Slides, so. Oh, she has the PDF. Yeah, we are good now. Yeah. Can you check, Uma, from your side something is bugging? There is some sound coming from your side?
Yes, sir.
You may start presenting, please. Go ahead.
Good morning. I am Uma Maheshwari from Kamaraj College of Engineering and Technology. My co-author is Falraj from AAA College of Engineering and Technology. Our topic is a comprehensive approach of air-level diagnostic methodology for landslides. Ma'am, next slide, ma'am. Actually, the landslide is one of the natural disasters.
Mrs. Maheshwari, do you have multiple devices?
No, sir.
Okay, there is
Only one.
some noise is there. Anyway, take it.
So it's one of the natural disasters that cause a significant damage to the infrastructure, property, as well as risk to the human life. Actually, the landslide does happen due to the movement of rocks or sands or earth down a slope. So this happens due to the increase in pressure that the water percolates into the earth and increases the pressure beyond the elastic limits of the soil. Thereby, the pressure is increasing and the strain created that makes our soil to be loosened and create a landslide. So the natural disaster that causes major damages to our life as well as the infrastructure. So by developing a reliable and accurate system for detecting the landslide, we can save our environment. So this is our project proposal is that is we are using a soil sensor and accelerometer sensor for detecting the landslide. And the major challenge in this system is how to place a sensor, where to place a sensor for getting the accurate results. So that is the major problem in the real time. So we just do it in a macro simulation, how to place a sensor, how depth it has to be placed. So that is all done in MATLAB. So this is mainly used in our disaster management as well as for environmental monitoring. Next slide. So this is what we have done, literature survey. These are all the places that actually discussed with the different kinds of sensors for detecting the landslides. And most of the things it's focusing on how to use sensors and how we can apply in our daily life. So in more papers have discussed about how to place sensors to optimal results, for getting optimal results. So we actually done that part. So this is our configuration. We are also using the same kind of soil moisture sensors and accelerometers for prediction. And the predictions actually compared with the threshold value. And if there is a deviation, so the corresponding notification has to be forwarded to the authorized person with the help of ASP8266, and it is stored in a cloud. So for our future reference. So this is the challenges. So different kinds of soil having different threshold level for elasticity. Like clay soil has different elasticity, whereas the alluvial soil has different soil elasticity. So we have to fix the threshold. That is to find this is the value where the landslide is going to happen. So we have to identify the threshold correctly. So that is one of the challenges. And second one, I already told calibrations of sensors, what kind of sensor we are using, whether it produces the accurate results and where to place. So these are the challenges. And so this is the result and the discussions. We have a we have created a prototype and we have tested that the soil taken from in and around the Virudhunagar of Tamil Nadu. So each kind of soil has a different we are working with only clay soil, but we are taking it from different regions like dry regions, for dry geological location, and particularly water. So we have correlated the moisture sensor result as well as
Uma, it seems like you have trouble in audio connection from your side. We cannot hear anything. Can you wrap up? Can you check any audio connection deficiency at your side? Yeah, now audible, but with with noise. Yeah, go ahead. Yeah, finish it up.
MATLAB simulation, so that we are so all the parameters are defined in MATLAB, and we are giving the
Uma, if you don't mind, can you check your audio connection or we will finish it off here. We have your presentation and we are reading here. Everybody can read through. But some question answer stuff, maybe it will be difficult for us to give suggestion or ask any queries. So maybe we'll put a stop here. So we'll move on to the next presentation. If it is okay with you. I hope so. Huh? Yeah, we need to stop. And back to Arpita.
Our next participant is Kavyashree Chaudhary.
Kavyashree, if you are there. Oh, she's here. Okay. This will be offline, so she will be presenting from this room. And Uma, if you unshare your screen, that would be nice. I think you can hear us. Maybe audio from your side is wrong.
Good morning, respected sirs. Hello. Good morning, Could you just adjust this? This is fine. Good morning, everyone. Myself, Kavyashree Chaudhary, scientist, Agri Engineering, Assam Agriculture University. I am going to present my work on use of hydrologic and hydraulic models for flood inundation mapping. My work is based on the Pagladia watershed. Pagladia watershed is a significant geographical area contributing, having various streams, rivers and tributaries contributing to the overall geography, overall hydrology of the region. Let's come to the study area. Pagladia watershed or Pagladia River is a northern bank tributary of the Brahmaputra River in the Indian state of Assam. The Pagladia River originates in the Bhutan hills and flows through the Baksa district and Nalbari district before its confluence with the Brahmaputra River. Pagladia River is perennial, shallow, and is mostly known for its flash floods and high discharge rate. Like most of the watershed, Pagladia watershed also faces an enormous number of issues like flood risk, soil erosion problem, and water pollution. For this, proper management and monitoring is necessary. Modeling helps in assessing risk associated with flood and helps in simulating various scenarios. The elevation of the Pagladia River is 52.69 meters above sea level. Climate is humid subtropical winter climate and annual temperature is 27.12 degrees centigrade and it's 1.15% higher than India's averages. Annual precipitation is 70.52 millimeters. Talking about the Pagladia watershed area, it is 781.23 square kilometer. Pagladia river length for the study area is 73.84 kilometer. My objectives are to estimate the runoff of Pagladia watershed using hydrologic modeling and to generate flood inundation map of Pagladia watershed by simulating the runoff hydraulics using hydraulic modeling. Here I have basically used two models, HAC HMS and HAC RAS for hydrologic modeling and hydraulic modeling. The datasets used here are DEM data from the source Copernicus having a spatial resolution of 30 meter, land use land cover from the source Sentinel having a spatial resolution of 10 meter, hydrologic soil group data from HISOC having a spatial resolution of 250 meter, satellite data Sentinel-2 from the source Copernicus having a spatial resolution of 10 meter, and rainfall data for the year 2022 IMD gridded data 0.25 into 0.25 degree, 25 degree. The data used was for the year 2022 because it could be seen that in Assam in the year 2022, mostly in the month of May and June, a flood occurred in most of the districts of Assam as per the news. So first, let's come to the metrology flow chart. First, I'll tell about the HMS model setup. So first, I have chosen two rainfall events, May and June. Since HMS is an event-based model, therefore I have chosen May and June because most of the rainfall occurs in Assam mostly in the month of May and June. So first in the HMS model, after choosing the rainfall event, I have chosen basin model, meteorological model and control specification. These models need to be set in the HMS environment itself. And for the data preparation for the HMS model, I have firstly prepared the land use land cover map and soil hydrologic map, and combining these two, I have prepared the SCS curve number map. After that, I have delineated the watershed in the HMS environment itself, and for the loss method in the HMS model, I have selected SCS curve number, and for the transform method, I have used the SCS unit hydrograph. After that, using the net rainfall data for both the month of May and June, I have routed it using the Maskingham method and simulated. Finally, I found the discharge for the both month of May and June. For the HECRAS model, I have set different geometric data like centered line, river banks, flow path and cross sections. And in the RAS environment itself, I have chosen flow data, boundary conditions and Manning's ends. And after that, using the simulated discharge, I have found, I have calculated three types of maps like surface water elevation, flood inundation map and velocity map for both the month of May as well as June. These are the results. Like for the HMS basin model, as you can see, the river I have considered from junction 1 till sink. So there are, we have found 5 sub-basins in the HMS basin model, and I have shown the hydrology summary table for the month of May 2022 as well as the hydrology summary table for the month of June 2022. As you can see that the peak discharge occurred on 18 May 2022 for all the sub-basin, junction, sink, reach. But in the month of June, the peak discharge occurred mostly in 17 June 2022, and for some sinks and reach it occurred in 16 June 2022. Here we are showing for the month of May and for the month of June both the rainfall data in the form of bar diagram and river hydrograph. So as you can see that the peak rainfall occurred on 18th May 2022, and for the month of June the peak rainfall occurred in 15 June 2022. Similarly, we can see the river hydrograph that the peak discharge occurred in 18 May 2022, and here also the peak discharge occurred in 16 and 17. So this is the preparation for the river geometry preparation for HECRAS model. The first diagram is showing the cross-section digitized river line, bank lines and flow paths, where I found the number of cross-sections to be 120 and distance between the cross-section was 400 meter. And I have shown here the cross-sectional view of river Pagladia generated for the month of May as well as for the month of June. As you can see from the cross-section that the depth, that the elevation of water in the month of May was less than the month of June. And here are my maps, Pagladia velocity map for the month of May, then Pagladia water surface elevation map for the month of May, and Pagladia depth map for the month of May. Similarly, for the month of June, here are the Pagladia velocity map for the month of June, Pagladia water surface elevation map for the month of June, and Pagladia depth map for the month of June. Finally, the conclusion, here I have, after the validation, I have found flood inundation validation with Sentinel-1 SAR imagery. First picture is showing before the flood event occurred, and the second picture is showing after the flood event occurred. So we can conclude that using the HMS and HECRAS model, the flood inundation mapping can be found for this type of watersheds which is having high risk of flood. So the floodplain map for the month of May indicated more chances of flood in Manas National Park, Baksa, Banganpara, Nalbari and the Nalbari-Baksa highway. Among these changes of flood in Manas National Park is more critical as the depth of inundation of flood is more in that particular area. The floodplain map for the month of June indicated more chances of flood in Baksa, Tamulpur, Banganpara, Nalbari, Maroa and Barbhag. Among this area, Baksa and Barbhag have probability of more amount of flood as compared to other areas. Thank you.
Sure. Spoke like a train. Good job. to meet the time. Okay, now the floor is open for online, offline folks to, like attendees, to ask any question or any suggestion for Kavyasri. Please go ahead. If not, Dr. Dikshit or I will ask questions. Please, anybody, anything, any query for Kavyasri?
So, Engineer Kavyasri.
Yes, sir.
Jagabandhu, can you wait?
Someone is having question, please.
Yeah, please.
I'll reserve my question for now.
Yeah, please wait for it, and we have a question here. No.
Yeah.
Dr. Pramod Kumar, please go ahead.
Hello. Yeah, can you hear me?
Yes, I can.
Prabhat, please wait. There is a question offline here. Then you will ask the question.
Yeah, I have one question. Did you check with the observed data?
Observed data?
Yeah.
Which
like,
data? Like
for the hydrological model, you have got the result of discharge, right?
Yes.
So did you check it with the...
Yes. Calibration was done for the previous year, like 2021. And after that, validation was done for 2022.
Okay.
Using the SCS curve number, only that parameter was considered.
Curve number was the parameter.
Yes. For the hydraulic model.
Okay. And for hydraulic model?
For the hydraulic model, Manning's toughness coefficient was used.
Did you calibrate it?
Yes. For the previous year again, 2021.
Okay. That was not shown, let's say.
Yes.
Okay.
Yeah. Oh, nice. Prabhat, you can ask, please. Your queries.
Hello. You have used 1D model or 2D model?
This is a 1D model, sir.
Okay.
Madam, how you extracted the data from the... Can you reliable for the 30-meter drum resolution? It does same cross section can be in a real field or not? Can you check it?
Yeah, sir. I could not understand your question.
Cross section you have
extracted.
You have extracted the cross section from the DEM.
Yes, sir.
Cross section from the DEM data, right?
Yes, sir.
Using HGRS.
Yes, sir.
So whether it is
sir, actually, after I simulated the cross sections and only then I have extracted it from HECRAS, sir, not the DEM data, sir. After I have done the river cross sections and all that, all the geometric data, only that I have extracted the geometric data.
From there, no?
Yes, sir. From the after the geometric data have been set, only then I have extracted.
Okay. Jagabandhu, you can ask.
So, Engineer Kavyasri,
yes.
So did you consider evapotranspiration also in your study?
Sir, evapotranspiration was not considered here.
Okay.
Is it going to contribute to the study if we add?
Sir, pardon, sir?
The ET will be contributing to your study or not? He's asking. The evapotranspiration should be used or not?
Sir, actually, I have not felt that it should be used, so I have not used. Mainly, it was for like flood inundation mapping, because the Pagladia River in Assam, actually in Nalbari district, it is very course changing. Every time it is changing course, and maybe that might be the reason that flood is occurring every year in that particular area.
Jagabandhu, you are okay with the answer?
Sounds fine.
Okay, Kavyasri, question is not for you. It is for most of the folks who are working on HECRAS and HMS model, okay?
Sir, also I also have one question actually.
Yes, sure.
To ask from experts, sir.
Sure. So,
actually, sir,
you go ahead. You go ahead, ask. You ask, then I will ask. Yeah.
Sir, from all the experts, actually, I want one answer, because I was working in this particular river, and what I found that generally we cannot purchase the data every time. So when we use the DEM data, 30-meter data, so there is one problem that 30-meter data, we get the older data. And like while extracting the older data, again, the river is changing course every year. Right. So what happens is first when we get the DEM, and after that when we do the river geometry and all, we find some problems actually for the course changing. So what should we do actually?
Yes.
I have heard is that like many of the senior professors are working here on Pagladia River in IIT Guwahati also.
Yeah, they will help you. And in that exact aspect, my question is not for you to every scientist. We have so many presentations on HECRAS and HMS. So when we have the river profile digitized, so we actually do it wrongly. So river profile should be actual, and with DEM we cannot really get it because for a perennial river, because the DEM tells you the river bed is completely flat when water is there. In real sense it is not. So that is the reason we must go to field and really from certain location have our on the same stick and wire and find out the depth and make a kind of a graph and use that one and just convert that one to the HECRAS model. So that would be accurate.
Thank you.
And we are not following it. And everybody is saying we are using DEM. DEM is wrong because for a water body, if it is not a dry river, how could you get exact thing? But now things are better. I do not know Palgharia river, whether it is perennial or it dry up sometime. If it dries off, then the LiDAR is the best thing, that is cheaper. We can have a drone with a 3D. Nowadays you don't need 3D camera. There is some motion based 3D analysis. It will take photos, overlapping photos, little bit extra skill needed, and you can analyze, create a 3D information of the entire area. And it doesn't cost much. Maybe IIT can purchase or it has money, and it is too easy. Only the processing thing required, and you can get river profile nicely, but in dry condition. And then use that one for your model. And most of the model we just digitize because it is needed for a HEC and just go for it. So that's not accurate. So not for you, for everybody. So you did good job. And we can go for the next one, okay? There is a question for you.
Regarding the change of the river course, okay, scientifically you should use the latest theta, okay, latest cross section theta, but since it's a shallow rivers, even if you have that approximations that you didn't have a recent cross section, more or less it comes in that range, because if you look at the travel time or flood attenuation point of view, okay. So it doesn't have a much error because it is a shallow river, very shallow river. So that is the reason. That's what is scientifically we should have the river cross section every year or every 2 minutes. If you don't, yeah. UG?
DTM, terrain model, but terrain model, if it is a river, it is not dry river, then it will be the same problem. But Dr. Datta is saying that you have a question like river changes the course. If I'm doing the study, I use the whatever now.
Yes.
So don't worry about it was earlier one. But good work. Carry on.
Thank you, Kaveshri. Our next participant is Biswajit Pradhan. Biswajit, you there?
Can you ask for Dr. Mazarika if she is there?
No, sir, she did not respond, and also she did not send any PPT.
She is not there.
She is not here.
Okay.
Biswajit?
Biswajit, are you there? Biswajit? This is Saturday.
Is it Professor Biswajit Pradhan?
I'm not sure. Maybe
Biswajit
Dr. Datta
Pradhan.
knows. Biswajit Pradhan it is. Yeah, it is Biswajit Pradhan. Yes.
No, what I am asking, is it Professor Biswajit Pradhan whom I know from GIS and remote sensing?
No. A student of Professor Khatua.
Okay, someone else.
You can go for next. Okay.
Our next participant is Ravi Ranjan.
Yes, I am present here.
Okay, Ravi, please share your screen. You have 4 minutes to present.
Okay. Is it visible?
Yes, it's visible.
Okay. So Good morning, all. My name is Ravi Ranjan, and I am BTech fourth year student at Central Institute of Technology, Kokrajhar, Assam. So, my topic for discussion here is the direct estimation of manning roughness coefficient for in-bank flows in Mindring L-level channels, a study of Gaurang River, which is in northeast India. So the exact estimation of manning roughness coefficient is crucial for the precise modeling and simulation of river channels and as well as for the flood management. It also depends on the surface roughness, vegetation of section and shape size, irregularity and alignment of channel. Hence, finding an appropriate value is complex. Standard N values are available for straight, uniform and smooth channels in natural materials. Dependence on bed material size, stream power and bed form complicates estimation of N. Appropriate value of N for meandering and irregular channels are still being researched on. Experimental values of N from laboratory models of meanders are available in literature and the other research papers. However, in a river, real-life values of N are unavailable. So, meandering occur in several natural channels, especially in the northeast rivers like unconsolidated alluvium in the Barak and the Brahmaputra river. So, a study of flow characteristics of these channels is highly important for sustainable floodplain management. So our objective from this paper is to access the value of N for in bank flow in post-monsoon season and compare with the values of N, which is experimentally data from literature or the Ventry Chow data. So our study area was the Gaurang River, river in the north tributary of the Brahmaputra, and it is in a lower Assam of Kokrajhar. It is a typical mid-level channel. And we have categorized it as per the Ventry Chow, which is a natural stream, a minor top width at less than 100 feet and a clean binding, some poles and source, which is already in type D over 8.3. So what methodology we have used? So first we have selected the river and selected the position where we can take the data. So for depth, we have used the PGM type of current meter, which is where it is feasible. So first we have did the survey, leveling and prepared the cross sections. After that, we have deployed our current meter and use area velocity method to measure the discharge, and we have used slope area method for estimating N values. And we have also done the grain size analysis for river materials. So these are the photographs in which we have see that we are using current meter in the first right side, and in the left side we are adjusting our current meter. So results which we get are ranges from 0.01 to 0.034, and we have by comparing from Chow, which is the minimum value 0.33 to maximum 0.045. So the part of discussion here is that the values we have obtained is lower than the specified in standard, which is widely used in literature. And the flows in Mindring River in plains with sandy alluvium appear as being more than those estimated on the basis of value available in the standard literature. More measurements over different flow ranges model study would have to be undertaken, and the finding of this and similar future studies would contribute towards a better understanding of flow characteristics and variation of N in Mindring River in alluvial plains. This is important for floodplain river restoration, sustainable water resource management. Thank you.
Yeah, nice job, Ravi Ranjan. You finished in quick time. And the floor is open for the audience to ask any question or give any suggestion to him. Anybody?
He's given less time, so my question is also quite quick.
Okay.
Okay, sir.
How many cross-section data you took it?
Dr. Datta, I have a question.
Sir, we have taken at the 15 cross-section approximately.
That means you are presenting the average N value, or?
Yes, sir, we are presenting average N value.
Okay, but you could have showed that.
Not exactly average, sir, but this is the value which is which vary from 0.01 from the 0.021 to 0.034. It's a lower and the maximum the n value we have calculated from the different cross sections.
Okay.
Jagabandhu, you can ask.
Yes, Mr. Ravi Ranjan, when you are talking about any figures, so the way you have written this is pick, Instead of doing that, better you name the serial number, put the numbers of the figure 1, figure 2, figure 3 like that. And when you talk about the results, you can also improve the presentation. The way you have presented here in this textual form, it would be better if you present it in a very comparative way, in a form of table or something that will be more readable. Now coming to when you are talking about the future scope, for example, floodplain mapping, river restoration, are they just generic or you have some idea about that, given that you are from BTech?
No, sir. I have only the ideas about it. We have. I didn't study more about this.
Okay. So you understand what I said in terms of that figure numbers, etc. In
Yes,
slide
sir,
number
yes,
6, for example, you have written pick dot colon. It's not the way to present. So just like this, it's you can improve the presentation style also. Yeah. So that will help.
Oh, okay, sir. Thank you for your suggestion, sir.
Sure. No, Robbie has 5 minutes only, so he didn't make it really elaborate. So he will do good next time. And Robbie, I actually commend your work. This is different from most of the presentation we saw. This is very practical. You guys do the field work. And to this, my comment is from the earlier presentation. So we can do this kind of analysis to make the river profile developed. And also I have an easy idea, very cheap idea. So we can take the fish finder sonar and a boat. So just go with the boat and take the fish finder sonar, take readings at several locations in a cross section and come back and map it.
Sir.
So then that would be very cheap.
Yes, I have done this in this method, sir. Actually, we have taken 15 sections where not every section we can go in the river and we take the data. So somewhere we have to use boats.
There you go. Thank you. So this is the one almost all hack people, we need to do it and it will be really very useful and practical and really correct. Okay, thank you. We'll go for the next presentation. You can unshare your screen.
Thank you, Ravi. I again call Bishwajit Pradhan, if you are present.
Do you have his number? Or?
Yes, sir. He was present a few minutes back. I called him, but he's not answering. Bishwajit Pradhan.
He seems there. Okay. Robbie, you need to unshare your screen. Huh?
Mute.
Already did? Okay.
Okay. Moving on to our last participant, Zoeb Ahmed Khan. Zoeb, you are present? Yeah.
Yes, ma'am.
You have 4 minutes to...
Audible?
Yeah, you are audible. You have 4 minutes to present. Please share your screen.
Is my screen, can you see my screen?
Yes, we can see your screen. Please make it full screen. Yeah, it's fine. You can start.
Okay. Good morning to one and all. My name is Zoeb Ahmed Khan. I am a PhD scholar from Delhi Technological University in the Department of Civil Engineering under the guidance of Dr. Bharat Jamnani. So today's research topic is effects of torrential rainfall and floods on the changing landscapes and their impact assessment. So the content of the presentation would include the introduction, objectives, methodology, result and analysis, and followed by the conclusion. So the natural and human activities have a significant impact on the land use and land cover all around the globe, which leads to alteration in its landscapes and consequent changes in the natural process. So these dynamic changes, basically, they disrupt the delicate balance of the ecosystem, which increases the danger of floods by altering runoff patterns, reducing natural water retention and eliminating important vegetation that formerly acted as a natural barrier against flooding, leading to damages to household and livelihoods and to human life and property. So land cover features are integral components of the ecological balance, and it is worthwhile to study any changes in the that occur in the environment, especially in the light of growing urbanization, which leads to decreased permeable land and further increases the risk of flooding. The alteration in land cover in any form is considered to be the most significant factor of the global change that influences ecological system with an impact on our surroundings. So, for instance, we have seen that in Kerala floods in 2018, from 2018 to 2021, we have witnessed a large-scale flooding in Kerala, and many districts are affected due to that flood. The primary cause of the 2018 flooding could be the prolonged precipitation that occurred in the month of August, while the recent floods that occurred in 2021 are basically due to the mesoscale cloud bursts, which occur over a very small area, but the intensity was very high. So the floods were the recent floods of Kerala were the most severe instances in the history of flooding in the region, and the flood has resulted in significant environmental damage and disrupted their daily lives. So the objective of today's presentation, I have taken from the following 14 districts in Kerala, I have taken the Idukki district for the study purpose. So the number one objective is the investigation of rainfall levels that are experienced during severe flood events, specifically in the years of 2018 and 2021 of the Idukki district. Secondly, the assessment of alteration in the land use land cover prior to and after the floods of 2018 and 21 in the Idukki district, changes in the LULC area due to the floods, and ascertain the extent of flooding in each LULC category. So this is the study area, which is the Idukki district. So it is one of the 14 districts of Kerala, and it is characterized by rugged hills and steep valleys in the western regions. The area, it consists of area of 4,365 kilometers square. Further, it lies in the hilly region. So due to the presence of hills, the main landforms in this area are structural combined denudational hills. And the hills also possess a shallow layer of soil and consist of Precambrian basement rocks. So mostly this region, the Idukki district, lies in the western Ghats region, except the eastern block.
Joheb, go fast.
Yes.
You are spending more time on discussing those things.
Okay, sir. Okay. Yeah. So the methodology would include the rainfall data, the creation of LULC before the floods, and the creation of LULC during the floods, and determining the effect of flooded areas. So the rainfall map has been created for the month of August 2018 and for the month of October 2021. So here you can see the extensive rainfall that has occurred in the August 2018, which also resulted in the consequent floods. Similarly, there was heavy rainfall that occurred in the October 2021, which resulted into the floods and caused heavy damage to life and property. Here you can see the western portion has high rainfall, and the eastern portion has considerably less rainfall. It is due to the factor
Biswajit, you have 1 minute left.
Okay, ma'am, sure. It is due to the presence of the Western Ghats. So this is the LULC of 2018 and 2021. It is characterized into five landforms: the agricultural part, the barren, the built-up, the forest, and the water body. Here we can see that in the LULC of 2021, the barren land has significantly increased. As you can see, the yellow color is represented by the barren land. It is due to the escalation of landslides that have occurred after the rainfall and excessive flooding. And we can here see that the changes in the area, that water body has gone up by approximately 15%. The built-up area has also gone up by 57%. The agriculture and the forest areas have reduced. And consequently, the barren land has significantly increased by 132%. This is owing to the factor of escalation of landslides, which have converted the forest area into the barren lands. Now, this is the final effect of floods on the LULC. Here I have zoomed out the figure to actually show the pixels of the flooded region, so that the flooded region can be easily visible. Here you can see that the dark blue color is represented by the flooded region. So these are the two pictures which indicates that the flooding has taken place during the floods, the LULC of 2018. And similarly, it has affected an area of 20.86 kilometers square. The built-up area accounts for 0.48 square kilometers. The forest accounts for 10.6 kilometers square area. The agriculture accounts for 5.11 and the barren area accounts for 4.67 kilometers square. Similarly, we can see from LULC 2021 during the floods, the flood has affected a total area of 19 square kilometers, comprising of 0.24 kilometers square of built up area, 6.23 square kilometers of agricultural area, and 2.8 square kilometer of barren, and 9.9 square kilometers of forest areas. So you can see the most affected landforms in the Idukki district are the forest, followed by the agriculture, then barren land, then the built up land. So for the conclusion, the LULC map has shown a rapid increase in built up water and barren areas. The agriculture and forest regions has decreased substantially, which is due to the conversion of these regions into the barren areas. And it is found that those regions which are converted from forest into the barren areas are majorly due to the landslides occurred in those regions during the time of heavy rainfall. And there are several papers that are published regarding the landslide susceptibility zoning by various researchers in the past for the Idukki district, and I have gone through that as well. So it consequently proved that whatever the barren land has increased, it is due to the escalation of landslide that have occurred. And the floods have created havoc in these regions, resulting in submerging 20.86 kilometers square area and 19.25 square kilometers of the LULC of 2018 and 2021. Thank you.
Sure. Joheb, floor is open for you to answer some queries from our attendees. Online, offline, anybody have any question for Joheb? Please directly ask. Anybody?
So Mr. Khan.
Yes, sir.
So in your LULC map, it looks little kind of not so conventional. Like you are using red for forest. Is there any particular reason? For example, water and the blue that you have, which is generally done every time. So it gives an impression, this is the green stretch, this is the water body. What is the reason behind, or rationale behind all this? Are you getting my point?
Yes, sir. Yes, sir. I got your point. Generally, we take green color for the green color for forest. I know the dark green color.
Now, what is the reason for putting it as red? I mean, there must be some reason behind it.
No, sir, there is no as such reason behind it. Actually, I just wanted to make it, actually, initially I was taking the color green for the forest, but I just wanted to make it more representational in the view that it is much more clear, because the most of the area is covered by the forest. So that is why, just to have a clarity, because mostly the land is covered by the barren land in the 2021 LULC. So just to have a right color combination, that's it. Nothing more than that.
So related to that, so when you talk about the increase in water body, the square kilometer increase in water, so what exactly is happening? How does it, because increase in built up area sounds correct, or the increase in the barren land is okay, but how does that water body is increasing in area from 2018 to 2021?
Sir, actually, there is a rise in level of the lake that are present there. There are different reservoirs that is the Idukki reservoir is there, and similarly there is Mullapariya reservoir is there. So basically it is representing the rise in the water levels that have occurred due to the floods, due to the excessive rainfall that have taken place over the years. That is why there is a 15% increase in the water bodies.
That's what my point is. So when you talk about that increase in water body, is it just post-flood, or it's kind of, because when you are talking about LULC, it's not necessarily representing, because you are talking about the year also, 2021, 2018.
Yes.
So when you compare two different years, it is not necessarily pre-flood, post-flood. It's about
yes,
kind
sir,
of doing the scenario.
Sir. Yes, sir, I got your point, sir. Actually, the rainfall has continuously occurred from 2018 for 2021 or even 2022 also. So over the period of years, due to the excessive rainfall that has occurred in the region, that is why it is there. But yes, you are right. The map that is shown here is pre-flood map. It is not during the floods. But over the period of years, it is just the general changes that has happened from 18 to 21. That is it. That is why we have seen that there is a increase in the water body. So due to the rainfall only, it has nothing to do with the floods. But yes, from the rainfall of 18, 19, 20 and 21, there is a slight increase in the water bodies.
Yeah, good answer. Actually, there's the dry year is 2018, so you have lake level went down, and then 2021 continuous flooding year or something, or higher rainfall year. But I have a question. related to your conclusion. So you told that you have studied.
Your audio is not audible, or I am not able to listen.
Hello, can you hear me? It's okay. Can I get another one?
It's working, sir.
It's working. Hello, can you hear me? Can you hear me?
Sir, your voice is breaking. I don't know if it is with everyone or with me only.
Maybe it is breaking.
Yes, sir, the voice is breaking.
Hello, can you hear us?
Okay, Joheb, I have a question related to your conclusion. So,
yes, sir.
So you are talking that you have studied so many papers on landslide. So how you think you will include this land cover change study to your like next work on landslide modeling or something?
Sir, we can have the results from the landslide susceptibility zoning, because that can tell us the areas of affected zones, affected areas that have the largest that are the largest landslide susceptible areas, and we can just superimpose this map with our map so that we can identify the areas and make a relation in relation to that floods.
Okay. Yeah, good answer.
We can have a flood susceptibility mapping, and then we can do the landslide susceptibility mapping along with the rainfalls. So we can have an idea that what are the affected areas due to landslide and what are the affected areas due to floods.
Sure.
So we can superimpose both the images and find a result related to that.
Just to comparison, okay.
Yeah, so just for the comparison.
Very good. Yeah, good job. Yeah.
Thank you, sir.
Bye. Biswajit, are you there still or? Biswajit? Mr. Pradhan? No? Did you text?
Yes, sir, I called him. He's not picking up.
And Dr. Hajarika, are you there? Lima? Dr. Hajarika? We missed both. So we are missing two.
Yes, please give a big clap to Professor Panda as well as Jagavandhu Dixit from online mode. Really did these sessions managing it very thoroughly and also interacting with the participants. So with this, let us conclude these sessions. Jagavandhu, once again, thank you for really conducting these sessions. So we will have a 10 to 15 minutes break because we have a keynote lectures. So from 11:15 we'll join it here again. Let us have a 15-minute break for tea.
Sir,
Thank you so much, sir.
Dikshit sir, I request you to.
Jagavandhu, thank you. Good job.
Thank you, sir.
Yes, sir. Dikshit sir, I request you to send me the evaluated sheet. We'll have the validatory session after lunch break. Maybe.
Sure, sir. I'll send it as soon as possible.
Okay, sir. Thank you, sir.
Thank you so much. Thank you so much.
Thank you, Jagavandhu. Yeah. Good job. We did good.
Everyone. So now we are proceeding with our next keynote lecture by Dr. S.K. Barik sir. So before I invite him for his keynote lecture, I would like to give a brief introduction about him. So Professor S.K. Barik sir is a professor of ecology in the department of ecology in Northeastern Hill University, Shillong. He has published 40 research papers, 8 books, and 20 technical and research reports. His works on the community forestry during past 20 years have contributed substantially to the development research and sustainable forest resource management in the northeastern India. He was elected as the lead fellow by the Leadership in the Environment and Development International.
Ajit, sorry for intervention. Please stop it. Let me start because this is a 15-year-old CV you are reading. So leave it. Yeah. So, unfortunately, I have not updated my CV in the new website. So you have taken it in default. So that is a 15-year-old CV. So leave it. I'll just give the next one. Now this is good enough. Yeah.
Okay, sir. Okay, sir. Sir, so I invite you to start with your keynote lecture, sir.
Yeah.
Thank you, sir.
Is it visible?
Yes, sir. Yes, sir.
Is it visible? The slide
Yes,
is
sir.
visible?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. It's visible, sir. And you are audible also, sir.
Yeah. This is a work which I am going to present. It is not my only alone. It is a team of 65 scientists who are working in Tawang River Basin. The objective was to establish a country protocol that how to really develop or plan a sustainable basin river management plan. So they are top scientists of the country were involved, and I was the coordinator. So I am presenting on behalf of all of them. Dr. Datta was also involved here, Dr. Haridas, and many other people are there. You know, when we develop a basin management plan, expertise from the diverse disciplines is essential because starting from the fishery to the microbes to the biomass estimation to the geology, hydrology, what not, everything, any environmental component you name. So you need to really take care of them. So the planning is a very massive exercise with diverse expertise, and it is not that shallow expertise, a deep and high level expertise is required to really develop a sustainable management plan. So what I was just giving the example of Goa. Yeah. So you will see that what are the important components of a planning process. First thing, we must know that cumulative impact assessment. So earlier in India, we were doing individual projects, we were assessing and trying to give a solution to that particular project. But later on, it is realized globally that no, in one project, if you do, the cumulative impact has to be assessed because it is simply not 1 + 1 = 2. It is actually exponential impacts are there. So in fact, it is the A plus B, suppose A project and B project, we are assessing the impact of individual projects. But in fact, it is the A plus B, it goes exponential the impacts. So cumulative impact assessment came into force. So now it is an essential component of any planning process. Then basin carrying capacity. So how many projects a particular basin will really sustain? So that is the second point. Landscape level biodiversity management plan, because it is a basin level, so naturally a number of ecosystems are there. So at the landscape level, how do you manage the biodiversity? And of course, when in the construction phase, before we start 20-year perspective plan for all the basin development management, 20 years plan we actually develop. So these are the 4 components in any basin management plan if you want to make it sustainable. So this is the example I'm just giving, 13 hydroelectric projects in the Tawang River Basin, total targeted 2,809 megawatt. And starting from the elevation, you can see from 1536 up to, you can see 3,357 or something of that order. So it is from the, you can say, subtropical mid-hill region up to the very high hill region, these particular proposed projects were there. So these are the maps. So what is happening? So how do you approach it? So the methods are important here. There are several methods are there, but what is the best method which we have followed? And we have proved that yes, these are the ideal methods. Say for example, impact assessment for individual projects. So we write that holistic approach we have taken. So domain specific methods for baseline data generation, impact prediction and mitigation. Cumulative impact assessment, multi-level approach, basin level, project level and socio-economic level. So you can see here any cumulative impact assessment, because this was the first in the country which we developed for the entire country. By MOEF, we gave the policy documents. So the network analysis, matrices, GIS, mathematical impact models, mathematical indexing, checklisting, and expert consultation. So you will see all sorts of models we have to use and all sorts of methodology available to us. We have to put into, that's why it is a multi-level approach. So multi-level approach means at basin level you have to do, project level, and socio-economic level. E-flow is a very big thing because building block methods are being used, but it is a very, very highly controversial and really it is incomplete in most of the building blocks. So we try to give a holistic view and try to include as many building blocks as possible. So here in our case, we have taken the ecosystem structure and function and services, hydrology and hydraulics, biodiversity, livelihood, and cultural. So these are the 6 you can see: ecosystem structure function service 1, hydrology 2, hydrology hydraulics 2, biodiversity 3, livelihood 4, and cultural is 5. So these 5 building blocks we kept, keeping the Tawang River Basin in mind. It's not necessarily that only these 5 blocks will be restricted. Depending upon the river basin characteristics or the importance of the local cultural and economic importance, you can add some of the other building blocks depending upon the necessity and the situation. So carrying capacity assessment is another gray area which people were not able to do. So we have used the multi-criteria approach, basin zonation, population influx, forest loss, minimum river flow, that is the environmental flow, and free flow river length, combined environmental index. So we use the tools like statistical models, indices, GIS, and trend analysis. The 20 years perspective development plan, that is the integrated and strategic approach, stakeholder consultations, analysis of data generated for situational assessment, formulating the vision, developing the basin strategies, and detailing the implementation. And landscape level biodiversity management plan, where species specific, ecosystem specific, and landscape level approach. So three tier. One is the individual species. If there are certain species, you have to take a different approach. Ecosystem, critical ecosystems are there, vulnerable ecosystems are there, identify them, and develop the management plan. And landscape level approach, so naturally at the landscape level, where the ecosystems are interacting, species are interacting, so at the landscape level too. So domain-specific methods followed by geospatial methods for landscape level planning. So in a nutshell, these are the approaches, and this is the backbone of the whole talk. So you will find that what are the methods you are going to use, because as I told you, some people can use the descriptive methods, some people can be highly mathematical, but it is a hybrid method which we have used. It is the data collection, after that the descriptive, and of course we have the models and other quantitative approaches. So that's why treated as one of the best in the country. In fact, it was the only one that time when we developed, and the whole country is following now this approach. Even the other countries like Nepal, Bhutan, and Bangladesh, they are also following this approach. So individual impact assessment, as you all know, so whether it is the biological or physical and social environment parameters have to be quantified. So you can see the air, noise, geomorphology, soil, water, land use, land cover. I think all of you know what are the parameters, but I'm not going through the details. So these 6 environmental or physical environmental component we have to do. Similarly, biological environment, you will see ecosystems, plants, animals. At times we also do the microbes and the soil arthropods, etc. Habitat fragmentation, destruction due to construction activities, and so on and so forth. What are the aspects you have to see? The right side column describes. Human environment, existing development infrastructure, socio-economic profile, culture, religious profile, resource use, traditional knowledge systems, and all these things you have to see that, and all these are indicators which in the right column. So as an example we have given here, physical environment, so how air, noise, geology, geomorphology, seismicity, soil, water, climate, land use, land cover. So changes in land use, land range pattern, changes in land quality. Your project target, you can really do the physical environment assessment, similarly biological environment and human environment, all these things are right for project. So you can see the entire basin, the starting of the projects, how we do the survey area. So those are the for plant species we surveyed these areas. Naturally, you can see that 10 kilometers on both sides of the tip. These are the animals. So you see the cameras were set up, animal survey areas. So you will find that same way the air sampling stations were there. You can see for each project there are timing where the guidelines of that area. So you will see the surveyed villages. So you will find all these villages were surveyed extensively so that we capture the most details. You can see the total number of households surveyed 1,917, and total number of households is around 9,477. So that is 20.23% households of the PRB have been covered in the survey. That is a very, very good representation. And field visits were made to 59 villages. So out of total 34, so 25% of the villages were visited. Despite sustained efforts, villagers of 13 villages declined to participate in the survey. That happens. People oppose also many projects. So these 13 villages didn't participate. So thus the total number of villages where both village and household surveys were conducted reduced to 46. The number of villages surveyed thus presents around 20% of the TRB villages. In addition to 46 villages, village level data could also be gathered for another 9 villages. Thus village level data available of 55 villages. So 23.5% of the villages are there. So remember that at least 20% is a good figure for sampling. Okay, this is the slope, this is the broad climatic zones, these are the dam, this is the model, these are the soil map, these are the land cover map, these are some of the important unique like Fasciolactis plant, the edible algae which is based upon the local economy. These are some of the habitats where the black mat crane, the most controversial animal species in that Tawang River basin. So we mapped their habitat. So this is the result of the camera trapping in the night. You can see these are the organism mammals we got it. So these are the methods we followed. These are the microscopic algae. You can see these are the species. These are the langur and the macaque. Arunachal macaque is the endemic species here, right? So all these parts were hawks, mundas, certain species like panax and many other species. So all these things were documented very carefully. So these are the cultural things. You will see that 108, you can see that from where the river Tawang originates, from the 108 holes, so a lot of cultural significance. So like that, we kept on doing that for individual projects. What are the possible impacts, mitigation measures, what can be done? So those red letters are the mitigation measures. What are the possible impacts in the black letter? So like that, for each project, we kept on documenting it. And what are the solutions? So possible impacts on flora and fauna, possible impacts on certain floral components, impacts to seismicity, hydrology and water quality. So like that, individual project specific impacts and mitigation measures we prescribe. So we'll see for each project like that, all the 13 projects were done. So now comes the cumulative impact assessment. The cumulative impact assessment is targeted towards the VECs. I think all of you know valued ecosystem components. Whether it is the water, it is the soil, it is the animal, it is the plant, it is the all these are land use, land cover, all these things are the socioeconomic, physical and biological parameters which are going to be affected or going to be impacted by the proposed activity. Those are called as the valued ecosystem services. So VECs are the fundamental unit of planning. So how these VECs are going to be affected, once you know the impact, then you can really develop the mitigation plan or development plan subsequently. So here is the indirect impacts. How do we define the cumulative impacts? Cumulative impacts could be the indirect impacts or could be impact interaction, or so that's why this is the interaction. So project 1 and project 2, you will see that the impact of project 1 and project 2, there which we were assessing previously, but the interaction between these two impacts and combined impact, that was missing. So in the cumulative impact, we are taking care of this interaction between the impacts and the individual impacts. In the sum total, we are taking the impact on the VECs. The same way, the planned activity, whatever you do, you will find that impact 1, 2, 3, 4 and interaction among themselves, and that is the total cumulative impact. So when you do the cumulative impact, any planned activity also you have to see, and of course the impact of the project also you have to see. So then only you can assess the impact. So you will find here type of cumulative impacts and main characteristics with the example for Aringal basin. So time crowding, time lag, space crowding, cross boundary, cross border, fragmentation, compounding effects, trigger effects. So you will find the main characteristics and examples of the river basin. So all these things are characterized. Same way, what is the CIF cumulative impact assessment framework? You will find that first is scoping, then is the collection of baseline and assessment of impacts, identification and development of mitigation measures, evaluation of significance, and monitoring and evaluation. So what are the tasks? Identifying regional issues of concern, select appropriate regional VECs, identify spatial and temporal boundaries, identify other actions that may affect the same VECs, identify potential impacts due to actions and possible effects, consideration of alternatives. Similarly, collection of baseline data. So all these things you have to do in detail. So actually, ideally, one river basin takes around 1.5 years to collect this data itself. So ideally, whoever is given the responsibility or when anybody approaches you, you must take at least 2 years time period to complete this type of massive exercise where there could be n number of projects starting from 3 or 4 to n number 50, 60 projects. So depending upon that, you must keep your time. Otherwise, the work will be very, very raw and it will not be really appreciated. So steps in cumulative impact assessment. So step 1 is scoping phase. So there you will do the identification of VCs, identification of the spatial boundary of CIA, identification of temporal extent of CIA. Scoping phase 2, identification of other existing predictable potential projects and human activities that could affect the VCs, identification of natural and environmental drivers that also impact the conditions of VCs. Then third step is the establishment of a baseline status of VCs, and step 4 is the assessment of cumulative impacts on VCs. Step 5, assessment of significance of anticipated cumulative impact. Step 6 is management of cumulative impacts, design and implementation. Step 7 is stakeholder engagement. So these are the 7 steps you have to follow for any CIA exercise. So tools used for CIA for Toan River Basin, which you used for scoping, collection of baseline and assessment impacts, all these activities which you saw in the last slide. So what are those events and what are the tools used? So this is the table. So expert opinion, matrices, modeling, carrying capacity analysis, GIS, network and system analysis, expert opinion, all these things are questionnaire survey, checklist. So all these tools you can use. So naturally you see impact models. So examples of task detailed, assessment of cause-effect relationship between reduced projects, and there is no limit to the models. Diverse type of models you use which are the best suitable. There is no fixed, depending upon the data input, you have to see that models are also varying. So numerical modeling, change, landscape level indicators, spatial analysis using GIS and geospatial modeling, impact models. So now the forecasting of the CIA, cumulative impact assessment analysis, how do you do? So in our case, we did it. Quantitative estimates of cumulative impact were undertaken for developing a social development index, SDI, for each affected impacted village, and a cumulative impact assessment, CI index, to assess the relative contribution of each proposed project to the cumulative impact additive on the river basin. So what does it mean? So how the social development index means, if you want to see that suppose there are 65 villages are there. So out of these 65 villages, which are the villages they are the worst affected? So that will give you the social development index. So that social development index will combine more than 100 indicators, socio-economic indicators, and we develop the social development index. Then we predict that if this particular project is coming or the total cumulative impact of all these projects, which are the villages which are going to be worst sufferer, accordingly you can take the mitigation measures. Same way the cumulative impact assessment. So out of those 13 projects, so what will be the worst impact on the environmental factors? So those 5 which I showed you, those 5 valued ecosystem components, which project is impacting how much? So then the combined calculation we did and we developed a CIA index. So this SDI index and the CIA index were our backbone of this assessment, and accordingly we rejected the project or we kept the projects on. So you will find this is the SDI. So all these things are starting from land use village level. Again, the indicators are there, use of private land for different purposes, number of households, sex ratio, literacy in village, livestock and value of livestock, average annual earning, all these parameters, and finally you can see there are 10 headings are there under that. So many parameters, more than 100 indicators we developed, and each indicator data has to be collected and it has to be provided. Accordingly, we will develop the composite index of socioeconomic status. So you'll find that at least weighted economic dependency ratio of these indicators, the first 19 are self-explanatory. However, the subsequent ones need some elaboration. So that's what we have done. So now completing the CI index, you can see ecosystem structure and function and services. There are several indicators for which the data were collected. Under this category of effects, the following have been considered: forest area loss per megawatt, carbon stock loss per megawatt, ambient air quality, periphyton and zooplankton density, net primary production, change in turbidity, total coliform count, IS, that means invasive alien species invasibility, dependency of villages and hill streams, spring water, in total 9 M1 effects. Similarly, biodiversity, we have these parameters. Ecosystem vulnerability, so many parameters. Hydrology, so many parameters. Cultural and livelihood, you can see they are interesting, this one. You will find that in that area, their dead body will be cut into 108 pieces and thrown into the river. So if the river doesn't have that much of water, so naturally dead body will not be decomposed or it will not flow downstream. So that will create the environmental problem. So we have to maintain that much of depth of water, whatever hydrological parameters or water requirement you have, you must ensure that this much for the cultural purpose you have to do it. For physical purpose, for say fish breeding, you have to do that this much of depth is required. Suppose chlor is there or any species is there, cytothorax are there. So which species needs how much of water? All these quantitative data you need, and finally you decide that what you think the optimum level of water, that is the E-flow, to estimate. So dependence on natural resources. So you find that CIE index was very extensive and very detailed parameters were collected, and based upon that we developed. So this is the CIE index. You can see here for you can see on the past row, all those are the different columns. They represent actually different projects. And for each project now, all these 6 aspects of projects VECs were quantified, and the total combined index values are these. And based upon that, you can see the total combined index, you can see 1.03, 0.82. So those projects which have more than one, we said that these are not feasible. They are environmentally destructive. So accordingly, we rejected. So it is a very quantitative term. You can see 2 projects are straightly rejected. And of course, you will find that this 0.9, 0.94, they were also, but you will see that later on result. So downstream assessment of E-flow. So this was basically headed by Dr. Vasi's group. And you can see that Expert Appraisal Committee for River Valley and Hydroelectric Power Project of Minister of the Forest recommends 20% of average lean flow, 90% dependable year for lean season, 30% for monsoon, and 20 to 30% of average non-monsoon, 90% dependable year flow as minimum religious level. But this was very arbitrary. There was no logic behind that. So we tried to establish a very quantitative approach, very logical way. So that's how our work was unique. So you will find that we collected the Central Water Commission groundwater data directly for trend and discharge series. We used it, and the building block method we used. You can see that using the stakeholder consultation process to set objectives, environmental conditions of the river, assessing modified flow regime, using flow-dependent indicators and non-conjunctive human requirements, identifying the critical components known as the building blocks of the flow regime for government environmental conditions. So these are the 5 building blocks we defined, as I told you before: river hydraulics, river biodiversity, ecosystem structure function and services, cultural requirements, and livelihood requirements. So all these detailed parameters were there. You can see the analysis of hydrological parameters. So HECRAS model was followed for hydrologic modeling, analysis of river cross sections, lateral flow contribution analysis, 90% dependable log flow analysis. So these were the inputs, and finally you'll see that, for example, for ecosystem structure and function, if we want to maintain the salinity of which is the minimum threshold level, because below that the life forms in the river will be dying, or that will not be able to sustain. So this is the minimum threshold level we decided based upon the detailed study. Say for example, water depth for cytothorax species, you can see that is the 0.5. So so that for 0.5, if it is the meter, so how much water discharge? So minimum threshold lean season discharge at any point of the basin. So what should be the? So you have to see that at least we have to give that this much of discharge we have to as a at least Qmax actually, by mistake the unit has gone. So this is the cubic meter water. It tends to be there always at the 5 Qmax minimum. So where the suppose breeding area of this particular species, this is the Mahasir. So you will find that for that we need more actually, but this is the in general, and for the breeding area that is a different actually. So all these things are phytoplankton density, how much we need. So for this, all this requirement is defined. Then how much of water is required in the lean season, that is defined, and this will be the minimum threshold. We cannot go below this. So that's how we decided for each building block. These are the requirements. Accordingly, so all these things were worked out. You can see the river section. All these works were done, and this is the minimum total reserve solid all water quality parameters. So the red one is the minimum threshold. So we maintained that. So accordingly, these models, they decided that how much really we need minimum values. So accordingly, we see that all these things values have been there. So acceptable value for the river basin during the lean season, during the monsoon season. So different values, and we then gave them based upon this. Instead of a random 20%, 30%, it is based upon the quantitative values. You can see here, say for example, livelihood. So how dead body disposal. So how much depth, wide lean season we need, how much depth, how much. Accordingly, we give the each project wise. So what are those novel aspects we introduced here? Primary data were used in all aspects, including CWC raw data. 6 building blocks were identified relevant to the basin. E-flow was determined based on threshold flow, giving equal importance to all the indicators building blocks. Threshold flow for each indicator was determined based on extensive knowledgeable public expert consultation or simulation modeling. Ecosystem and sociocultural parameters were given importance in addition to critical habitat of a few species. Say only fish habitat is generally considered, but we have given many other species as well. So the carrying capacity was another gray area where the method was not there. So you know that the upper asymptote, that is the K, when we determine the carrying capacity K, that is a very, very highly debatable subject. How do we define? So we took this free flowing river length, that how much of the river should be left completely from the obstruction. Free flow river should be there. So total river length and inter-project river length. So inter-project river length is intact. So we take that is also a good one. And of course, where the dams are not present at all. So the total river length, we fixed that, say for example, 1/3 of the river length should be completely free from any obstruction for the sustainability of the river system. Population influx, there has to be limitation. Forest cover, E-flow, upper elevation limit. Say for example, 2,500 meter or 3,500 meter above, there should not be any project. So straight away 2-3 projects got rejected. So like that, SA index, socioeconomic index, what should be there? So like that, we decided, we developed the methods for each. So no project above 3,200 meters should be constructed except the microhydels. Like the population, we see that not exceed 57,474. So 66% of the project of the area will be under forest cover. 40% of the main river length, not 30%, 40% of the main river length should be free flowing, free of any project. So like that, these values were decided based upon the analysis. So these are the things. So free flowing river length in TRB. So we calculated total forest loss threshold. So you will see that K is equal to 66%. So accordingly, it is much below that. After all the HPs also comes, 5 for 19 hectares, then also we are much above the 66% threshold. So the parameter study to characterize different VECs in TRB. So these are the zooplankton, blah, 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 which I have told. So this is the logistic model, carrying capacity model, which we had. So you can see that even 95% confidence limit. After that also, these two projects were rejected, and post the Nyamjangsu, where is that? Yeah, so this in the red zones also we rejected actually. So this is the how to sustainable development and landscape level biodiversity management plan. I think many of you are engineers, so you will not be showing much interest, but you know biodiversity is an important component for the ecosystem services, based upon which even the flow of water is dependent. So it is very fundamental to that, which is to be done very carefully. So biodiversity conservation management plan very detailed, and you can see that these are the prescriptions. So these are the management plans based upon the basic data which you collected. So you will see that wildlife corridors were identified, where to be connected, all these details have been done. So species-specific conservation models, so for example, black-necked crane, or it is the red panda or Arunachal macaque, they are endemic species, threatened species, so how do you conserve them? So individual specific conservation measures, plus the ecosystem level, certain plants also you have to see, ecosystem level management also you have to do. And of course, perspective development plan also another chapter, the total development including this. Also, what are the construction activities, how to really regulate all these things. So when we develop a planning process, it has to be extensive and intensive both, so that we can take care of the detail, each and every problems which we are expecting or it might come in. So all those things are done mathematically, and then you develop the plan. So in my opinion, one should give some time, but it should be perfect, it should be intensive, so that it is really useful, or it can be at least near perfect, you can say. With this, let me thank the organizers for inviting me to talk, and thank you, Ajit, for reminding me. In fact, I completely forgot about this. So since you called me at 10 o'clock, it's good. Thank you so much. Special thanks to you. Thank you.
Thank you, Professor Parikh, for presentations. I just invite now directly to Professor Dr. B.K. Das, because he has a next flight to go it, so he can present his thing within 10-15 minutes. After that, I will come back to the questions, any questions to the Professor Parikh. Is it okay, Professor Parikh?
Yes, please go ahead. Please go ahead. Professor Das, please go ahead. You should have told me before, I could have finished early.
Yeah. because it's always difficult to do for full things in online mode. So it is a cascading delay of 10 minutes only. So. Please unmute, Dr. Das.
Unmute, I have unmuted. I am just seeing this sharing.
Okay. There is a vertical.
Yeah, that one I am just.
On the top right, there is a vertical arrow.
Yeah.
Now you can share your screen.
Sir, you just have to open your PPT window. It's already shared.
Presentations we have? No.
Sir, share the same way you did and just open your PowerPoint, so it would be okay.
Now it is visible.
Not yet, sir. You need to share again because you stopped sharing.
Visible?
No, sir. You need to click on the share button, that top right, just left to the leave button, red button. So click on that and share again your screen. You might have opened the PowerPoint, but it is not shared yet. Sir, maybe makes the Teams full screen so that you can see the top right. Second button from the right top is the share button. Mail might take longer time. Yeah.
Sir,
Visible now?
No.
You have visible?
No. So can you just reshare it? Go near to leave. There is a share button.
On the top right, sir, there is a share button on the top. So click on that and share your screen. That is just to the left of the red button, leave button.
Yeah. When you are putting, there are some column add to the reading list, add to the bookmark, due to.
No, not sir. That click on the share button, then you will see some windows below it, and just select your screen, how your screen look like, that picture will be there. Click on that, then it would be okay. Maybe.
Now it is.
No, sir.
Now it is coming.
No, sir. No, sir.
Not coming.
No. Maybe if you don't mind, can you email the PowerPoint to us? I don't know how big size it is. Email to Dr. Datta so that we can see it. We can put it here.
Naughty task. He's sorry.
If you don't mind, can you give a call to Dr. Datta in your phone, WhatsApp or something, so that we can help you? Just call Dr. Datta's phone if you have. Through WhatsApp, or you can call him. So, or Dr. Datta is calling you so that we can check your screen and can help you.
Hello.
Hello, sir. Just share it. It's a very close to the leaf bottom.
No, it is here it is red bottom, then we don't have, but down we have the things like your camera off, then mute, then your share. There is a share button there.
Yes, sir. Please show your screen.
Sir, yeah, just have the phone to the screen so that we can see. Yeah. Other way maybe. Yeah, that's the correct thing. Can you check?
This one?
Yeah.
This one?
Sir, please. Sir, please, in front of your laptop screen, sir. Just place your mobile in front of your laptop screen. Just we want to see your laptop screen so that we can guide you, sir. Where is that share option and all?
Yeah.
Sir, please put it in front of that your laptop screen, sir.
Yeah.
So there is a plus mark. Just beside of that, sir.
Left side or right side?
Sir, just little down, sir. Your camera is, sir, upward, bit upward. Sir, just bring it down. Yes. Sir, left side, sir. Left. Yes, sir. That
Yeah.
one. Yes, sir. Now, sir.
Sir, can you bring the phone to the down of your monitor? Down, yeah. We can see the little bit to the left. Something is there. This one record only. can you click on the top right? There is two arrows. Click on that. No, top right, completely top right.
Sir, extreme right, sir.
Extreme right.
Extreme right.
No, no, that is not the correct one.
Not that, sir. Extreme right one, sir.
Like in the corner of your monitor.
This one?
Sir,
we cannot
sir,
see
what
the-
is your size of your PPT, sir? Can you send it to us? We will.
You can go to the File Explorer so that we can see and
Sir, you can share your PPT here, sir. We will display it.
Or sir, I can request you, you just give a 10 minutes your experience. That is enough.
Yeah,
that's enough, sir.
without the PowerPoint.
Without the PowerPoint, you can give a 10 minutes experience about this Ganga project, what you are doing. That will be enough.
Okay.
That's what you can. Without PowerPoint also, we can give a 10 minutes present.
What we are doing for last 8 years in our study, if you look into this, we are mostly looking into the under national mission in Ganga. We are looking for the fisheries biodiversity aspect, and we have 3 stages of we are open. First stage, we are just going into the documenting the total fish biodiversity, then environmental parameters, then cage and socio-economic condition of the fishers. In that conditions, in second phase comes in the river restorations for the ranching programs with using different IMC Indian measure curves to see the stock enhancement in the river. In this case, now we are in this phase 3, we are mostly going for the basin approach. We are taking the wetlands, tributaries and distributaries, how it is linked in the main river channel, how it is contributing towards the Orthoganga concept. In this case, first we are looking into the biodiversity and production status. If you see, till now we have documented up to 215 fish species, 206 are native and 19 are exotic, and it is 144 genera in the different. And mostly fish hybridity contribute to the highest species richness, maybe 30 species and 46%. And out of that, you could see 30 mostly freshwater, 65 are freshwater in origin, and 35% are in the cosmopolitans, and they are distributed in the different years. You could see how the fish was initially found maybe 270 in 1822 by Hamilton. Subsequently, it is reduced to hardly 200. You could see around 146 species. Now we are seeing that the fish species in the present study is increasing up to 215. Again, look into this. This was also, we have 18 sampling stations we are documenting, and we will find Bridgeonor is the highest species, and followed by the Boxer and Paraka, and these are the places, and also the Norora. These are the three species will be high species dominance is found, and if we go to this, and we are now doing some of the stock enhancement of the Gangetic curve, because you know the freshwater fish there is very less stock enhancement. We are now adding to the cart around 15 species for the stock assessment, whether they are exploited or underexploited. All these things we are working on that, and if you see the exotic species are distributed maybe starting from African magoon to the common carp, and common carp is the dominated species in the most of the thing. And again, we perceive some of the big head carps and of the some of the African oscillated buffer fish. These are the dominating at the present context. Again, because of climate change, you will find there are some of the fish species they are dominating from the extended distributions are found, which is the impact of mostly climate changes. Again, we do if you see as per the conservation status, 10% of the fish are threatened, 15% nearly threatened and vulnerable. Around 73% are recorded species are least concern. And Tehri and Haridwar was confronted with the maximum abundance of threatened species. So we record mostly the conservation plans in these areas. Again, looking into the catch pattern, you will see upper stretch, you will see maximum contribution on the priced mass was found to 46%. Middle and lower stretch is found, you will see around 39%, and fish catch in Patna increased from 26% to increased to 26% here, which indicates there is a stocking enhancement program which yielded the catch structure increasing in the different rivers. And catch per unit efforts you are find West Bengal people maybe catch 7 to 8 kilo, and they could say Bihar is hardly 3 kilos. So, and Uttarakhand is also equally 3 kilos. So, which again, the catch varies from summer, monsoon and winter season, and you could see highest in the summer season at 57 kg per day, in winter also found in the most of the cases. Again, look into the craft and gears. There are a lot of craft and gear used and modified in the different things, and large wooden boats, and you could see small wooden boats are maximum, and tube somewhere the fishings are also they don't. And you will see the tube fishings are Uttarakhand is maximum, and you will see Bihar and other places, and you will find there is a cases of maybe medium wooden boats and small wooden boats are there, and dinghies are found in West Bengal, small dinghies. Again, you will see the selected fish restoration we started for the river ranching program, and we have 105 ranching programs we have conducted, and around 98 lakhs of fingerlings are released, and which impacted there is an increasing of the fees from 8.5% to 15%, which is a total impact on these things. And if you see, there are from 17 to 23 year-wise ranching. As if you see in 23 we have gone around ranching of highest number of fishes. And if you look into this river ranching, I told it was time series data, so that IMC as Prayagraj increased to 24%, and also share of IMC in total lending has increased, and Devagraj in the Prayagraj also. Again, if you see that, again if you comment to the Varanasi also, it is increased to 41%. Again, if you see Patna, it is increased to 20%. So there is the impact of these things. Again, we are doing an innovative way of breeding the things. We are collecting for the germplasm depletion, collecting the fish stock from the river Ganga, breeding, and same stock has been reached so that to prevent the germplasm contaminations. Today, you will see these are the evaluations, and spawn is the total. You will see when earlier it was small evaluation index was calculated 21 ml is a 2020, and compared to this 1964, around 2,984 ml. There are two ways of contributing this. Just reducing the small spawn, because of maybe gradually there is a collection is restricted, and secondly, the exotic fish is dominating and IMC population is reducing. Therefore, we are taking this type of restoration and conservation measures. Again, we are now targeting some of the wetlands associated with the river Ganga in the basin approach, and in each state we are taking there are biodiversity conservation, taking the stock enhancement in the reservoir using the CIPRI technology by cage and pen culture into the systems. And this will be, it is found that there are open fields at the highest biodiversity, then the closed field as well, and if you are seeing that we should have a maybe entrepreneurship over the years in the closed field is going up, and thereby so much algal pollution index are increasing. And there are today again we are covering a few territories in the Bengal, Matla River, Kosi River, Rupnarayan, Haldi, Jalangi and Ichamati. These rivers are brought into this page, and where we are just documenting the different biodiversity. Again, besides that fish diversity, we are just documenting to the total variety. You will find plankton biodiversity, maybe 144 plankton genera. The diversity of plankton is found in lower stretches as compared to the higher stretches. Similarly, benthic, 13 pollution indicator species for benthos has been documented out of 69 microbenthing. And this was the thing. Again, we have seen that last 6 decades, what is the changes in the environmental parameters, mostly water quality, where we found that the DO has increased and free carbon dioxide is reduced and nitrate concentration is raised because of eutrophications and nutrient decompositions. And these are the some of the things you could see. And other parameters like you could see, pH is also increase in alkaline pH condition, a decrease in hardness, conductivity, and improving of the river and water quality in this. And TDS is increasing because of the deposition of the nutrients in the riverine system. Though we have recorded the trace metals in the sediments and water, but that are not in the alarming conditions. Similarly, the microplastic is one of the important emerging contaminants that are coming. So we have documented in the fish how it is flow and sediment and water in the river Ganga, and we do not find this microplastic is not that much alluring, but in the long run, it is definitely detrimental to the systems. Then we have bisphenol A, algal pollution index as algae. We have find out in microcystis, alocasia granulosa, and other algal diversity relating to these things. And besides that, we look into some of the Hilsa fisheries improvement in this, and which is major concern. And Hilsa, because of Farakka barrage, migration stop. These are our constant efforts, and we are finding that there is a migratory route is established. Hilsa is migrating, and tagging experiment recovery, we have find 8 to 10% recovery of these things. And besides that, we have some of the initiatives like migratory route we are monitoring, and that will be impacting how the thing. Besides that, community sensitization awareness is the one of the things to enrich the socio-economic in line of Ortho-Ganga. We found hardly the Ganga fisheries is contributing to 10,000 to the economy, which is a very much critical phase. So we therefore now NMC is taking the Ortho-Ganga concept, looking into the economic development of the community in and around the river Ganga, and so many other agencies are involved, and we are just working in that concerning the socio-economic conditions of people and sensitizing in the different sides of the river Ganga. And today we found that maybe their economy varies from 4,300 to 7,300 rupees. So less to this. So, and our awareness campaigning for the dolphin and other things found that people are mostly awareing for the dolphin conservation, which is mostly required the aqua life because of the ability to dolphin is directly or indirectly related to the water quality improvements and other things. And in Cell, and we have so much online, offline programs to sensitizing, and besides that, we have different outreach activities. And Honorable Prime Minister recognized the activity in the Man Ki Baat programs. And these are the in nutshell we are looking in the henceforth next 3 years. We are targeting mostly on the basin approach of this. So with this, I stop my present talk. Thank you.
Thank you, Dr. Das. Even if slight bit problems with PowerPoint sharing, but you have really clearly stated it, how the CIFRI Calcutta is doing improving this fishery part in Ganga rivers, which is and monitoring the health of the Ganga. I think a lot of work to be done it, but the initiative taken by the CIFRI Calcutta is always needs appreciations from all the sides. With this, let us thank, with a clap, let's thank Professor Dr. B.K. Das. 1 second. So we'll go for the lead presentations. Okay, we are having 10 minutes delay. Oh, okay, that's no problem. 15 minutes.
Hello. So we will be having our lead presentation by Dr. Amiya Sahu, sir. And after this, we will be having the discussion with the Professor S.K. Barik, sir. Yes, this screen is visible.
Yeah. Full screen, please.
And please put it in the full screen, sir.
I have put it in full screen. Is it okay?
No, sir. You may stop sharing and do share again the entire screen. Stop sharing. Stop sharing. It is still sharing, I guess. And
No, I have stopped.
yeah, and click the share button and share the entire screen. Then it will go.
It was there, but now there is some issues.
No, it was okay last time. When you stopped sharing, it was okay. We could see your entire screen. So.
Yeah, you just once again share it, and when you share it, it will show the window shares, no? Yes.
No, fine, sir.
The or just leave and rejoin it. That is what. He left. Dr. Sau, can you rejoin it?
Yeah, I have rejoined, but again, same problem. What happened with Dr. Das?
You go to the share water.
Initially, yeah, I just.
Can you send your?
Yeah, just 1 minute. Just 1 minute. I'm trying. Because I have joined from Truth, I think. Is it okay now?
It should be okay now. Yeah, we can see your screen kind of. But we don't see the PowerPoint. So PowerPoint should be there.
No, is it coming now?
Just we're waiting.
Yeah, we have a blank screen, but we can. Yeah.
Put it in a full screen.
Is it coming?
Yeah, it has come, but put in full screen mode.
Sir, I have already put it in full screen. Just wait for a minute. I think it will come. Sir, whether it is visible with full screen?
No.
I don't know.
We will be okay if you click on the plus button at the bottom right and just cover your entire blue screen. So we'll be okay with that.
Which one?
Down, top, complete down the plus button. There 42% written, and then so increase, make it plus, so that.
His side it is a full.
Yeah, there you go. Yeah, but it is not coming to us. It is too much now, but just cover the blue screen, so we should be okay. And go with the clicking on the left side. 75% is okay. Yeah, perfect. Yeah.
Is it okay?
No, you just reduce. Further reduce. Yeah, it's okay now.
A little reduce, it would be okay.
Is it okay?
Yeah, it's good. Yeah.
Please start.
Okay. So
Please start. Yes, start.
Yeah.
Yeah, good afternoon, everyone, and thank you, Professor Datta, convener of RCRM 2024, for giving me this opportunity and inviting to present as a lead speaker, particularly on the environmental flows and what CIFRI has done since last more than 1 decade. But it will be very tough to present all the case studies, so I have presented here only two. One in Himalayan River, Tista, and another is in Mahanadi. So in the previous speaker also, Dr. Barik, he was speaking about the environmental flow and the basin management. But here I will be focusing more over river ecology because if you look at the ecology itself, if you can take care, we have seen that the fish is the ultimatum in the river because as an indicator. If the river pollution is there, we take as the fish as the indicator or microrenthus as indicator. So we consider, particularly in the environment of Minister of Forest and Climate Change, and also that if you can take care of the fish, you can take care of the river ecology. So with that, we started during, if I remember, 2006 or 7, we started the environmental flow study taking as the fish as an indicator species with the flow duration method, because there is a genesis in Indian e-flow studies. If you look at, mostly we depended on the hydrological aspect, particularly FDC. Then we went for the tenant and adopted the Western countries methodology, then BBM methods, and now 5SIM. And mostly at the last year, we work with under the Indo-EU water platform, where the University of Austria also together and Delft University. So recently we adopted major 5SIM, which is also the latest development in the environmental flow studies. So which methodology is suiting to our Indian rivers is very important. And also as because of the fish species also varies. So I think you all know when we define a particular river system, so it is not only the flow, it is the 4-dimensional structure which indicates the lateral connectivity, longitudinal connectivity, then surface, then ground water, and again spatial distribution. So this is a 4-dimensional structure. And not only the hydrology, but also morphology, geomorphology, that forms the habitat, and finally it goes to the ecological diversity. So when we talk about the river health or the ecological health, it depends upon the hydrology, geomorphology, habitat, and blah blah, all the parameters, particularly the water quality, quantity, everything. So let's talk why it is the fish. Come to the left side of this picture, how green, how blue from the tip top to the sea mouth. So how diversity is abundant, particularly in the hill stream. We have less number of fish. Say example, though, you have the phytoplankton, zooplankton, and more species is more towards the when it meets to the ocean or the sea, because you have a lot of basin inputs from the top to bottom, and also there are various habitats. And come to the right portion, which
Dr.
is just
Sao,
downstream.
Dr. Sao, can you click over the thumb rule of the slides are there? Your slides are not moving.
Yeah.
Just click on
The left side.
yeah. So now it is coming. Yes, yes. Please. Yeah. Yes, yes,
Okay,
yes.
is it coming, sir?
It's coming now.
Okay, so this slide, have you seen this slide?
Yes, I can see that. Defining the rivers. Yes.
Okay. Okay, right. So I have already defined what's the river and how the hydrology, morphology, and habitat plays the critical role for the ecological diversity. And you know, in the river, particularly, you have a flow regime, you have a low flow, high flow, normal flow, and the waterfalls. And every pulses or the flow regime has a critical role in the habitat constructions. Like, you know, have the keystone species, particularly in the fish, which depends on the different life cycle, and also the river ecosystem health to the flow system. And I was describing that how beautiful the left picture indicates the supporting lots of life, not only the plankton, zooplankton, benthic, fish. So lot of life they are supporting, but in the right side you can see there is a zero life. So that is what the importance of the e-flow, why it came into the picture worldwide. And we are taking as the fish because this is the topmost in the food chain. If you see, these are the top level organisms coming to the phytoplanktons and the zooplankton, then fish. So look at here, this is the what is the dangerous for this is the tunnel based powerhouse. We have particularly in Indian condition, run of the river, which is the run of the dam to powerhouse, which is just a e-flow that restrict the flow pattern. But this is the tunnel based powerhouse, which is very dangerous because in the downstream you don't have any much water which is required for the life. Now the concept of MOEF has come to the pump storage project, where you have the upper reservoir and lower reservoir, and the water comes for the generation. So this is little less the impact particularly in the river, but this is very important when the lower reservoir or upper reservoir they are taking up from the river water or canal water, that needs to be environmental clearance. So e-flow has to be, in all the cases we consider the e-flow is the critical factor for the river health. Now it is very well known that the Brisbane Declaration, then GRBMP, so they have all described with the key focus on the quantity, quality, and also timing. These are the three key factors for determining the e-flow, and depends on the socioeconomics, that depends on the particular ecosystem, how it demands. Particularly in Indian rivers, if you look at you have the spiritual, you have the cultural, you have the livelihood activities, but in Western countries, you don't have that much to add on. So that's what the BBM method is little having restriction when you are putting the blocks in different aspects. So when we talk about the fish particularly, we have considered these are the methods. I will not going in depth about the methodology, but having just a glimpse how the environmental flow assessment came into the picture. Originally, it was the ecology and the hydrology, the Tennant methods. Then we moved to the hydrology, ecology, hydraulic, geomorphology, and water quality and social aspect of human beings to certain extents. And now, if you look at the integrated water resource management, we have the social aspect, we have the human well-beings, then stakeholder participation, and economic analysis, particularly the citizen science. Citizen science also is a part of integrated water resource management, what we have done in the Ramganga Basin in the last year 2023. So there is a very holistic method when you are going for the environmental flow assessment. With this background, I have two case studies, but this Tista River when we carried out in 2010, it was just in the beginning of the e-flow study, though we have seen lot of methodology has been developed. So this methodology we have adapted with the Hackles method, and if you look at this Tista River, we have, all of us, because this is near to the northeast is Guwahati, so we have particularly lot of dams, particularly Tista 1, 2, 3, 4, 5, 6, and also we are working on how this fish pass and environmental flow can be integrated. This is called as the cascade of dams. When you are making so many dams in a particular river system, you are making the river not free-flowing stretches, you are making a small cascades. So just the tailless cascades makes more dangerous than that of the run of the river projects. Now, how we carry forward, particularly if you say it is initially we started with the fish as an indicator. So we do all the fishing methods, like you use gill nets, scoop nets, hook and lines, whatever the methods are adopted, particularly in the habitat. So we go for the sampling morning, evening, and night also, because some species they are natural, like they come to the shore particularly during the night and the feed during night. So we sample at different time. This is the night hook and line method. This is the dragnet method by scoop net, and we have find that particularly Tista is we have Schizothorax, the snow trout, and we have the Nucleus hexagonalis, which is known as the chocolate mahseer, and also indigenous Gara species, Botia species. So we consider as the snow trout and chocolate mahseer are the two important keystone species, particularly in that zone. Now coming to this, what are the different life stages we observe? We observe whether they are the brooders. Brooder means they are the mature, they breed, or they are the young ones, or they are the juveniles, or they, which is the spawning grounds. Different life stages, different habitat suitable for the breeding grounds, spawning grounds. And then what we do, you assess the habitat. Look at here, these two pictures, this is the pre-monsoon and this is the monsoon. The hydrological changes, this has inundated during the monsoon. What is the fish species this suitable for this habitat? And we consider this sediment, clay or whatever you have sealed, that is the suitable for the monsoon fish species. Similarly, this is the pre-monsoon season, this is the habitat, and this is the monsoon. So we have a comparison how the habitat has influence towards the fish diversity and particularly the food-free organisms. Now look at here, the seasonal, if you have the pre-monsoon, monsoon and post-monsoon, how they are particularly different season, different life stages they are suitable. Particularly pre-monsoon we have the juveniles, very small size, they adapt to low flow and stagnant water. When the flow velocity is 0.1 to 0.1 or 0.2 meter per second, they are mostly favorable to that. Whereas the monsoon, you have the gonads, these are the matured gonads. That means it needs that before monsoon, they need more water for the migration, particularly for the breeding. So these are the two key important species like migration and also the reproduction. So these are the two factors we determine the flow rate. And the post-monsoon, we have the juveniles of this 10 to 15 millimeter. So these are the criteria we see that which period is suitable for the brooders, which season is suitable for juveniles, so that water allocation will be suitable particularly for the seasonal pattern. Now look at, these are the matured schizothorax, these are the matured eggs which are ready to breed. Now this is the another aspect, as I said, the migration is very important, and we have seen the year-wise, as Professor Barik was telling, that not less than 1 year is suitable for the study. So we should take minimum of 2 years. So this was also 2 years study. If you look at the migration period, we have seen that when the Richardsoni or say chocolate mahseer or torta, what are the migration? Particularly we have seen the snow trout during the March, April and May, they move particularly upstream migration. Okay, and this chocolate mahseer, they have the May, June, July, August, September, they mostly go for the upstream migration, and October, November, they go for the downstream migration. And similar to case of the top, they are the June to October, September they move the upstream and downstream. So this is the criteria we consider, that which time or the which period is water is required for their migration and reproduction. That is what the water estimation, the quantification is required. It is, as you said, you see, generally what happens, all the models, say example, the HACRAS or FABSIM or MESABSIM, they need certain inputs like what is the depth, what is the velocity. But these are the two factors. Say example, what is the period of migration and the period of reproduction are the critical factors determining the flow. You see, the team is visiting in the spawn collection. These are the small stream which joins with the main river, and you see the juveniles. Then this is the habitat that is suitable for the juveniles. So that much of water we should supply for the juvenile sustainability. What is the depth requirement for that, velocity, what is the food habitat requirement. So these are the different life stages is important while critical analyzing the e-flow. And also, as we discussed, the food item is also important. What are the planktons? Generally, schizothorax, they are the grazers. They graze on the stone. I have not presented that particular picture. In the stone, you will get lot of marks. They graze on that. Particularly, they have the periphyton and the plankton ratio. So based on the migration pattern, reproduction, food and feeding, then we estimate, okay, these are the suitable, particularly the substrate for the lean, non-lean period or non-monsoon for the snow trout. So this is the
Dr. Sao,
to the particular model.
Just another 5 minutes, okay?
Sir?
Another 5 minutes because we are delayed lot.
Sure, sir. Sure, sir. So these are the habitat which require for this. Then, as I said, the methodology we work for the hydraulics, particularly we started with the HACRAS and also the flow depth relation and the cross section. We have taken the 500 meters. So we have used the ADCP machine. We have the different depth and current profile profiler, and from that we need the cross section. Then we have the depth suitability and velocity. This is very important when you are estimating the physical habitat requirement. So this species, what is the depth requirement? It is the maximum it should reach to 1. So like example, 1.5 meter depth is the most suitable for this species. Similarly, the velocity is 1 meter per second. This is based on the experimental fishing and different methods we adopt. Similarly, so if we also consider the different tributary methods. These are the HACRAS models, that I am not going. So we have developed a different scenario like 15, 16, 17, 18 cubic. So what is the depth and velocity is suitable, and finally estimated that the 18 cubic is very suitable for the during the lean season, and which will maintain particularly juvenile, as I said, 0.6 meter and the velocity of 0.4 meter per second. This is for the juveniles, not for the adult. And similarly for the monsoon, 129 cubic we have estimated. And coming to very briefly, as Professor Datta said, 4 minutes, I'll finish with that. So we have also considered the Mahanadi basin particularly. So in the Mahanadi, if we have taken from the Hirakud Dam to the Naraj barrage, which is almost 390 kilometers, we have the different habitat. In the top region, we have the Mahasir. In the middle, we have the Gharials, and the lower zone, we have the wetlands, which is the water is connected to that. So water should be connected to this wetland. That is what the e-flow estimations. Now, if you look at the fish species, we have seen that these are the total fish species, 113 species, and from that, you see, we have done the reproductive studies and also the migration pattern. We have seen that when it is breeding, particularly tor, that is Mahanadikas, that is Mahasir Mahanadi. So breeding season, we have seen that September, March is most suitable for that. Similarly, we have taken another catfish for the breeding, which period is the breeding fish here. Then this is the hydrograph. You can see that June, July, August, September is the monsoon season, having the flood season, different gauging site. We see that the pre-monsoon is suitable for the catfishes, whereas the post-monsoon is the Mahasir. So based on that study, we have find that the 60 to 75 cubic is with this water parameter is the requirement for the during September to November required for the Mahasir, and similarly for the catfish species. Now we have taken also the Delta Mahanadi, Delta Syrinus reba. This is the habitat rating methods like a suitable curve method, which is the suitable for the depth and velocity. Then we have gone for the FAFSIM method in the Kathojedi, which is the Mahanadi Delta, and we have find that during the lean season 750 to 800 cubic is the minimum requirement for this Syrinus reba, which is the keystone species. And as I said, the flood pulse is very important while you are estimating the e-flow, particularly the Peninsula River or the eastern rivers, not in the hilly zone. So because this water enters into the flood pan, which is the lifeline for the many indigenous fish species. And we have seen we have also published in that water is most required for the during the flood pulses for the surviving the indigenous fish species. We have certain publication in that, and major output that we have developed with the CWC guideline for longitudinal connectivity through dams. And also this has the guide with the Indo-E water platform. We have developed a guidance document for e-flow assessment and implementation in India. And also, if you look at the guideline, the first one is the optimum ecological flow must be estimated for the fish migration and recruitment. When you are considering the ecological flow, you should consider the migration and recruitment or the reproduction for the estimation e-flow. So I think with this, I thank you, sir, for giving this opportunity. Thank you, sir.
Just because we are delayed by half an hour, and delay in lunch break time is it's a punishing me also. So that's not delaying too much. So if you have a few questions, I think we can take it to Professor Barik as well as Dr. Sao. If you have some questions. Okay, no questions from here. Professor Barik, you are here? Okay. So I think we can straightforward go for the next sessions. That one.
Yeah, shall I stop sharing, sir?
Yes, sir.
Yeah. Thank you, sir.
Thank you, Amir Sahu, sir, for delivering
Thank
such a
you.
nice presentation. So now we are moving with our last participant presentation session of the day as well as the entire conference. So for this, I would like to invite Dr. Shrija Pekat ma'am as a session chair, and along along with her, Dr. Somennath Kuiri sir, associate professor from IIT Madras. I would like to invite him also to co-chair this particular session. So this particular session is about river ecology, mapping and modeling. So we are having total 7 participants, out of which 10 participants are having the large presentations of 10 minutes. So 8 minutes will be given to deliver their content and 2 minutes for their discussion. And remaining 2 are having short presentations of 5 minutes each. 4 minutes will be provided them to deliver their content and 1 minute for the discussion. So all the participants are requested to adhere with their time limits. And this session we will be having a best presenter. So for this, I would like to give evaluation sheet to our session chair. So let's start with our first presenter, Padmini Samal.
Hello.
Yes.
Hello.
Yes, Padmini, you are audible. You please start.
Okay. Yes. Okay. My. So is it visible? My screen is visible.
It's visible. You can start, Padmini.
Okay, ma'am. Good afternoon, all of you. Today I'm going to present on a topic that is a case study over Rusicula River Basin. That is water quality assess using the parameter of water quality index and mapping through GIS on the current present scenario. So as we know that most of the human Rusicula River is the southern region of Odisha state, and the river supply the Kandhamal and Ganjam district and essential water, and 70% of the population depends on the as a source of water supply for irrigation domestic purpose. And also it is reported that conductivity of Rusicula River increasing due to heavy siltations in some zones. So it is near some experimental validations for collecting the water sample from the zone of severe erosion as well as low, medium and sediment wear. So my objective of the study is to what is the current start of water quality index of the Rusicula River, and to study the conductivity of water and experimental validation of conductivity water from zone of high yield and low yield. So these are few literatures. And this is my study area, Rusicula River, which is located on the Ganjam district and the zone of 19 north to 20 north latitudes. And the catchment area is about 8,600 kilometers squares, and about 175 kilometers, that is from the origin of the eastern Ghat of Kandhamal district, and finally it ends the Bay of Bengal at Chhatrapur regions. So here is for the water quality index, we are the following this method for sampling the waters. Then we have some physical chemical parameters. What are the, we sample it, and then we have do some data analysis. Then we have calculated the WKI index by using Brown at the methods, and develop of WQI and mapping through GIS. So this is the methods by we have following to calculate the WQI of the water set. So so this is the standard criteria for which we, that means the excellent water quality if the WQI is 0 to 25. So this is the range as per the IS code provision. And this is after we have calculated the W, we have mapping through GIS, And we found that about 49% is on the zone of below 25. That means excellent good water quality. And near about 41% is about in the range of good water quality range, and rest about 9% is about on the range of poor water quality range. And whenever we, as it is study that that is conductivity increasing of this river. So, and this is the present status of the conductivity, which is sampled from the August 2023 to onwards or to up to date. So from this sample, we study the conductivity is not increasing that much, but here is a sample which I have collected on the monsoon period, basically on 2021-2022, and the zone from the Ganjam as well as Purushottam. And Ganjam is located, you can see the Ganjam from the figure, the Ganjam is considered as a high sediment yield zone, and Purushottam is considered as a low sediment, which we have done through another work. And when we have collected the sample, we got this, that means in the August 2021, it was highly increased. Now the August 23, that is now again it comes back to its original, but in Purushottam, the conductivity slightly increased. So the main reason we can say that the conductivity, so we find out what is there is some electrodiffraction index test we have conducted from this zones, and on the month, on the year of whatever the sample we have collected on August 2022, we have done some index tests, and we found that in the Ganjam, that means the sodium and magnesium and chlorine, which are the main parameters, which increases the conductivity comparatively to the Purushottam stations. We are also focusing other part which are high yield range, high sediment yield and low sediment yield, so that we can have a come to a conclusion. So we, on the conclusion part, we saw that means about 95% is in the permissible range, and which is fit for the human consumption. We observed that gradual rise of conductivity as we move towards the bottom of the basin, and the water conductivity test was done with high yield and index analysis of sediment particle. It was found the percentage of sodium, magnesium and chlorine are more water sample at Ganjam stations and in comparison to the Purushottam stations. The continual monitoring of this water quality indicator important for a healthy environment and understanding the river and natural ecosystem. Thank you.
Thank you, Padmini. It was a good presentation. Now we will ask questions from our participants. Any questions? Nobody is having questions. So I'll ask one question regarding your Padmini?
Yes.
Okay. Regarding your water quality index computation, have you selected different seasons? You were talking about 91% of water is within the permissible range. It's of good quality, right? So is there any, regarding the wet season and dry season, during both these seasons, it is within the same limit?
Ma'am, actually we have collected the sample on August, this is a monsoon period. So now we are collecting the sample from now because this is only a limited time, but we are focusing
it's fine, Padmini. I just wanted to know what is the difference it is showing regarding the wet season and dry season. Since you are collected only during the monsoon period, it's fine. Okay, thank you, Padmini.
Okay, ma'am. Thank you so much.
So, we have our next presentation by Dr. Sandeep Kumar Mondal. Hello, Dr. Mondal, can you hear us?
Yeah.
Okay. Please.
Hello. Yeah, am I audible?
Yes.
Yeah. Am I audible? Yeah.
Yes, you are visible, but your screen is not on the slideshow mode.
Presentation visible?
screen has to be made in slideshow mode. It's not in full screen.
Hello?
Your screen is not in the full screen mode.
Okay. Yes, ma'am. Is it?
It's visible to us, but it is not in the slideshow mode.
Is it fine now?
Full screen mode.
Not in the presenter mode.
Click on the liquor cup. Just kidding.
I think we can go ahead. We can see. Yeah. Is it coming now?
It is coming, but not in a full screen mode.
Yeah, that button. Yes, yes. No.
Yes, now I think it should come in full screen.
No. Just go to the fourth button. Right bottom, fourth button. We can see you are still on the first button.
Okay.
Yes.
I think because of slow network issues that might become like that. Yeah, is it fine now?
Let him continue now. You can start your presentation.
You can start presentation. Hello.
Is it showing?
Or Sandeep, just log out. Well, let me have another presentation and then we will come back. Okay.
Sandeep, stop driving.
Just unshare it. Just unshare it. We will put it to your check the networks and all the things.
Yes. Yes.
No. Your network is too low.
You are not audible to us.
Till yesterday we didn't have a problem. Today we are having a lot of problems.
No, the problem is from their side.
Okay, next.
Yeah, I think there is some poor network issues. I think, is it solved right now?
No, slide is not visible to us.
Hello?
Oh, yeah, we can put it here. Yeah, we have his slide.
We have a slides. We will show from this side. So you just unshare it.
I think there is some network issue I'm facing.
We are just sharing your PPT from this side. Is it okay for you?
Should be. It's not working.
Share कर लो.
That's okay.
Yeah, start it.
Dr. Sandeep, is it visible to you?
Hello.
Dr. Sandeep, are you online?
Hello?
Yes, you can start. You are not audible to us.
Am I audible? Hello?
Yes. Please start.
You can see our share screen now.
Hello?
Can you see our share screen?
Screen is visible. Your PPT is visible to you.
Ask him to talk, we'll just change.
We will be changing the slides from here. You can start your presentation.
Yes, sir.
Dr. Sandeep, am I audible to you?
Okay. Or let's go for the let us keep. I think he doesn't have a good network. It happens.
आपकी आवाज मतलब दोस्तों बहुत रुक के आती है। हमारी आ रही है, हमने आपकी PPT भी हमने अपनी तरफ से शेयर कर दी फुल स्क्रीन।
Ask him just to talk.
स्क्रीन दिख रहा है आपको? आपकी आवाज रुक के आ रही है बहुत।
Am I audible?
Yes, you are audible.
Yes. You can start your presentation. You just have to talk. Slide changing we will do from our side.
Bandwidth.
Slide changing we'll be doing from here.
अच्छा बट आवाज आ रही है ना, आवाज का इशू।
आवाज आपकी रुक के आ रही है, आपका शायद नेटवर्क इशू है। आपको स्लाइड दिख रहा है ना आपको?
Then let us go for next one.
Okay, ask him to talk in the phone. We will put him there.
लास्ट में आप ले लेना।
Because we are already late. Next one you call. इसको अनशेयर कर ले, पहले अनशेयर कर लो।
Our next presenter is Jayaprakash Nayak. This presentation we will be having at the last.
This one, yeah. Second में.
He is not submitted.
He's having changes.
No, it's okay. You can forget whatever is there. Let's start. Let's start it because already late. Okay. And we, already we have no. Share that. Take care. Share.
First one. Okay. Yes, coming.
Yes, please type.
Good afternoon, everyone. Myself Jeff. Sure, I can. Good afternoon, everyone. Myself Jayaprakash Nayak. My topic is environmental flow requirement of Godavari lower sub-basin. Environmental flow, the quantity, quality, and timing of water flow to sustain ecosystem and their benefits. Human livelihoods and well-being dependent on the ecosystems. These are the different e-flow methodology. First, hydrological index method, in which you have to use the 10N method, desktop methods, hydraulic rating method, habitat simulation method. There are the following objectives of my work: to characterize the low flow profile of Godavari River, to analyze the e-flow for the Godavari River by using 10N method. These are the first objective flow, low flow characterization, which you have to use the flow duration curve, which will be done by the variable plotting formula, in which you have to use the probability. P is equal to m by m plus 1, in which you have to determine the low flow domain, in which you have to take the Q20 the discharge corresponding to 20% exceeding probability, Q50 for 50%, Q90 would be 90% exceedance probability. If suppose you have to determine the measure of stream flow variability, you have to determine the dividation of Q20 upon Q50, same Q50 upon Q90, Q90 upon Q50. These are the low flow frequency analysis. You need to determine the 10 day minimum flow for corresponding to 10-year return period. Same 10Q2 is the 10 day minimum flow corresponding to 2-year return period. Same for 7Q10, 7 day minimum flow corresponding to 10-year return period, and 7Q2 would be for 2-year return period. 7 Q10 flow is used as a criteria for regulation purpose as follows. First, water quality protection for wastewater flow, habitat protection during drought conditions, chromic criteria for aquatic life, and local disappearance of flow. These are the EFR using a tenor method. And you have to use I have chosen I pertain the data from the 1966 to 2015 for my study location. My study location is Polavaram site at the Godavari river. These are the low flow profile for the period of 1966 to 2015, and these are the parameters of low flow domain. You have to mean MAR will be the 42 lakhs 4,724 in million cumex. Annual minimum flow will be 36.34 cumex. Q20 will be 4743.62 cumex, and these are the same is the low flow frequency curve for average daily weekly discharge data, low flow frequency curve for every daily 10 daily discharge data. EFR using tenor method. Mean annual flow rate will be 32 lakhs. This one flushing flow volume 200%, that will be 180.53. High flow season is from April to September, and environmental flow required is 40% of MAF mean annual flow. Low flow season is from October to March, and environmental flow is required 20% of mean annual flow. These are the hydrological hydrograph between the mean flow rate and average EFR. Resultant discussions: approximately 42 lakhs 4,724 million cubics of water flow in the Godavari river each year on average. Q20 correspond to 4743 cumex, Q50 equal to 503, and Q90 equals to 167.94 cumex. The MM10 for Godavari is 169.7 cumex. This means that the month of April, May, June, and July, the average EFR rate at the Polavaram site is 36.11 cumex. In the period of October, November, December, January, February, and March, it drops to 18.05 cumex. Outcomes. These are the. Thank you.
We'll take a question.
Okay, thank you.
We have to go further. Stop sharing. Stop sharing. Stop.
So our next presentation is Aritha Vivi. Hello.
Good morning all. Myself Haritha, research scholar from IIT Madras, working under Dr. Somendranath Curie. My topic of the
It has changed more.
slideshow.
Now it is.
My topic of the presentation is flood mapping of Chennai Basin by using microwave remote sensing and Google Earth Engine. So we all know comparing to west coast of India, east coast is more vulnerable to extreme events like cyclones and flood and drought. And I analyzing past few years of extreme events, Chennai is most frequently Chennai is most frequently flooded due to its geographic location near to Bay of Bengal and some anthropogenic factors. So there is a great loss of property and economy due to flooding. So here comes a need of flood mapping. So we are looking for a rapid and real-time flood mapping. So we are using remote sensing for this purpose because requirement of data sets and other pre-processing tools is require high cost. So optical remote sensing fails in the field when the extreme events, because cloud cover and penetration through cloud cover for remote sensing optical remote sensing sensors is not possible. So here comes the advantage of microwave remote sensing. Microwave remote sensing have an advantage of the sensor have an advantage of penetrating through heavy rainfall, and it is working on all weather condition irrespective of solar illumination. And here we have an advantage of we can map the flood before and after the events, and we have control on latitude and other geographical geometric parameters. My objective of the study is to detect land use land cover change analysis over the year 2015 and 2023. By choosing the reason of choosing these years, because the major two extreme events happened in 2015 and 2023. As all we know, 2015 and 2023 flood events are the have become the major discussion. So we are mapping flood of these 2 years, and we are doing a change analysis of flood mapping also, and we are finding out which of the land uses are inundated in these 2 years. So Chennai Basin have an area of 7,934 kilometers square, and which have rivers including Aranya, Kuvam, Kostalayar and Adayar, and some of the southern small river streams. And 2015 flood, we can say it is triggered by high storm surge and some of the development factors. And 2023 Mishong flood event poured more rainfall in the basin of Chennai and caused waterlogging in the low-lying areas. These are the major methodology. We have 2 parts, like we have land use land cover change analysis part and flood mapping part. We are using Google Earth Engine for this purpose. So we are using 30-meter resolution Landsat 8 collection 2 images for flood mapping, and we have prepared Google Earth. We have prepared training sets by analyzing 2015 and 2023 Google Earth images for land use land cover mapping, and CART algorithm is used for supervised classification. And we are also doing an accuracy assessment to validate the result. Then we are going for change analysis. For flood mapping, we are using synthetic aperture radar Sentinel-1 imageries, and we are going for pre-processing. Then we are doing spectral correction with a kernel size of 5 meter. And we are going for Otsu thresholding, which will categorize the pixel into water pixel and non-water pixels. So then we are doing an accuracy assessment there also. Then we are doing a change analysis with the land use land cover map and between the flood map itself. This is a land use land cover map prepared for 2015. As we can see from the overall accuracy, it has a 72% accuracy. The less accuracy is due to misclassification in between agriculture and fallow land. This is a land use land cover map for 2023. Here also the same thing had happened, and it has an accuracy of 71.48%. And here we can see the most of the development occurs in the coastal area of Chennai Basin, and the most of the forest area is on the western part of the basin.
Come to the conclusion.
Okay. These are the histogram for 2015 and 2023. So we are using VV band for flood mapping. This is a flood map we have prepared. The accuracies are shown here. So here comes the change analysis of 2015 and 2023. As we can see, for land use land cover map, urbanization, there is an increase in built-up area and a decrease in water body. This shows the perfect examples of water body encroachment in the whole basin. And we compare the flood map. There is an increase in flood inundation area. This is the land use land cover inundated in each year. So let me come to the conclusion. When we come to 2015 and 2023, almost 58.08 kilometers square of area is increased in urbanization. It's almost 4%, and there is a decrease in water body, that is almost almost 4%. A decrease in water body is there, and the encroachment of water body and increase in urbanization area almost, and all the increase in barren land also contribute the increase in flood inundation mapping when we compare to 2015 and 2023. The research contribution and utilization of the work is, we are focusing on mainly real-time rapid flood mapping. So the results we got from the study we can use for further calibration and validation, and the data processing and other data requirement in this study is less. So we are only using satellite imagery and some codes for the processes. So we can go for a rapid flood management and planning sessions. So future plan of my study is by using satellite altimetry, we are finding out the flood map, and we are using some other using some other microwave satellite for acquiring the microwave images, because the challenges in my study is acquiring the data during the exact day of flooding. So this is one of the challenges of my study. The OTSO algorithm is mostly applicable in where the case of bimodality is present. So here only slight change is there in bimodality. So I'm going for an local adaptive OTSO thresholding for further studies.
Thank you. Have a clap. Sir, we are not taking questions there because people are there here. So maybe another just 10 minutes. There are the 2 presentations left. Okay. Just unshare it.
Now we have next presenter by Shivani Koshta. Inki slide.
She's here also. Okay. Okay. Last presenters are all are here. Good. चल रहा था So when it will be over? 10 minutes. 10 minutes. Yeah?
Listen.
Good afternoon, everyone. I am Shivani Kosta from HBTU Kanpur, and today's topic of the discussion is environmental flow requirement for a critical reach of Bias River. So, first of all, we should know what is environment flow requirement. As one of our previous presenter already explained that environment flow requirement determines the quality, quantity, and the time that is required. That determines. No, it's open. It's open. Okay. Environment flow determines the quality, quantity, and the timings of water that is required to sustain the natural ecosystem and the maintain aquatic environment system. So in the current scenario, as we know that there's a lot of industrialization and urbanization. Because of this, there's a lot of pressure on our natural ecosystem, and there's a lot of energy demand. So as we know that some amount of energy comes from hydroelectric power plant, and the construction of hydroelectric power plant requires the construction of dams and reservoir. So when we construct the dams and reservoir, this affect the flow of a particular river. When the flow of a river get affected, it also affect the aquatic life of that particular river. So it is very important that on that particular river, there should always be a minimum amount of flow in that should be there, so that aquatic life can get a survival there in that particular river. So it becomes very important to regulate the reservoir so that a minimum amount of water should always be there. So actually this slide are not getting changed.
You can use up down.
Achha.
Up down, up down.
Okay. So there are various methods that is required, that is used to calculate the environment flow. The first one is hydrological index method. The second one is hydraulic critical method. The third one is simulation method, and the fourth one is habitat method. So here we are discussing two methods. The first one is Tenet method, and it is based on the hydrological method. In this, we have used the previous values for the calculation of environment flow. So in this method, we have calculated monthly mean flow and average mean flow, and by using these three relation, we have calculated environment flow. Suppose if mean monthly flow is less than 40% of mean annual flow, then environment flow will be equals to mean monthly flow, and if mean monthly flow is less than 40% of mean average flow and greater than 100% of MAF, then environment flow will be equals to 40% of MAF. And the last relation says that if mean monthly flow is greater than mean annual flow, then environment flow will be 40% of mean monthly flow. The second method is flow duration curve. These are the calculation which I have done for the Tenet method for the year 2009 and 2010. So in this we have calculated 40% of MMF and 40% of MAF. Then we have calculated the environment flow requirement. The second method is flow duration curve method. In flow duration curve method, it's a plot between the flow and the percentage time exceeded or equal. So in this method, we have used a study EMC, environment management class. If the environment management class is higher, it means that particular river requires more amount of water for the survival of that aquatic life. So this is the conclusion which I got, that environment flow values for the year 2009 is 118 meter cube per second, and for the year 2010 is 1547 meter cube per second. Thank you.
Thank you. So you have taken very less time. Okay. Okay, next.
We will be having next presentation by Padala Rajshekhar.
Online, no?
Is it online?
Rajshekhar, are you there?
Can you hear us?
Rajshekhar, can you hear? Rajshekhar, can you hear us?
Padala Rajshekhar, can you hear us?
Okay, you can go for next. No problem.
Okay, so now we will be having one offline presentation by Dr. Kamal Singh Gautam.
You will take 5 to 6 minutes only. Okay.
Good noon, all of you, and respected organizer, delegates, and participants. I am a Dr. Kamal Singh Gautam from Singhania University, Rajasthan. Thank you. Right now I am present my paper. Much what we know.
This key.
Much what we know today about the ecology of river. We owe of biologists, we have to focus a certain population of this that species of fish, invertebrate or plant that live in specific habitat within river. In contents had sometime been useful to think a whole river system as
please
being
silence.
essentially a large collection of unique places, each with our own local properties, depth, velocity, substract, water equality, and each potentially serving as a home to some unique set of the discriminating organism. That's my research location, Lower Ganga and Ram Ganga Doab in Farrukhabad, UP. It's a pick for disaster flood. We can recognize fundamental of characteristics which are the centralized to understanding the nature of river system. Is a river is a landscape system because of its immense physical extent. A hydrological system because it's participate a regional water cycling. A geographic system because it's a shape of the landscape of across of and its own channel. An ecological system because it's a support of drives and highly adapted biota. It's my research picks affected villages due to flood. It's a climatic condition in our research location. Continuance is the river of the predata of the conveyance of life. The plant and we undoubtedly among the fish habitat on the continually land mass presented and the originally marine biota. Thank you.
Thank you.
Thank
for
you,
sir.
miss.
I think with this, Dr. CJ, I want to have a questions or will be stop sharing. Okay. Dr. S.N. Corey, you have any questions because launch time and delayed by 10 to 15 minutes, and because we clubbed all these, no. Dr. S.N. Corey, please have some few words.
Yeah, so in this session, we had a few presentation on mostly river quality. So there was a little bit of hiccup in the connection, and that is quite common. Still, the presentation was well, and some of them has focused they are focused on case studies as well, and some theoretical background. So overall, it was nice. So I don't have a specific question. So given the shortage of time, so I don't want to ask any other question. Thank you.
Thank you, Dr. S.N. Corey. Please have a clap for that. Dr. Sija, can I have a few words before concluding this?
Okay, so thank you all the participants. All the presentations were going on within the timing and all. So some of the queries were there, but due to time limitation, I'm not going deep into that. So the presentation, experimental and theoretical, all those things, I am wishing you all the best. Go ahead with the future work which you were talking about at the last slide. So come up with a good research paper. Okay, thank you all.
So I can start.
So thank you. So we are here ending our all the technical sessions, keynote lectures of a 3-day RCRM 2024 conference. Now we are moving towards our valedictory session. So for this I would like to welcome all the dignitaries to the dais. Guest of honor, Professor S. Ravi, Dean of Faculty Affairs, IIT Guwahati. Chief guest, Professor Sudhanshu Panda sir, University of North Georgia, USA. Our convener and chair of RCRM 2024, Professor Subhashish Datta sir, Department of Civil Engineering, IIT Guwahati. Head of Center for Sustainable Water Research and Faculty, Department of Civil Engineering, IIT Guwahati, Professor Suresh Ekatha sir. And Professor Santosha K. Devedi sir, Project Director, TIH, TIDF, IIT Guwahati. So I would like to invite and welcome all the dignitaries to the dais. So please grace us. I would like to invite Professor Kanagraj sir, Head of the Center of Intelligent Cyber Physical Systems, to come on the dais. So before we move to our dignitaries' thank notes, I would like to honor all the session chairs and co-chairs who are present over here physically. So first I would like to call Professor Subhashish Datta sir, conference chair and convener, to felicitate Professor Sudhanshu Panda sir with Gomosa and a memento. Now, I would like to invite Professor Subhashish Datta sir again to felicitate our session chair, Professor Toru Terao sir from Japan, with Gomosa and memento. Now I would like to request Professor S.K. Dwivedi sir, Project Director TIH TIDF IIT Guwahati, to felicitate Dr. Pri Shija ma'am with Gomosa and Momento. So with this, I would like to invite Professor Subhashi Datta sir to address a few words to our participants and encourage them for sorry. Okay, so now I would like to invite Professor Suresh Katha sir to felicitate our Dean Faculty Affairs, Professor S. Ravi sir. और किसको? HSC सर को भी, कनगराज सर को भी. Now I would like to request Professor Subhashi Datta sir to felicitate our head of the center, Professor Kanagraj sir. Now I would like to invite Professor Subhashi Datta sir to share a few words to our participants.
Good afternoon to, I am audible, no? Okay. To all, I think last 2.5 days, it was really marathons, having starting from 9 a.m., closing at 6:30 and 7. The parallelly not at these e-classrooms, also the conference hall of mechanical department. I think more than 50 presentations in mechanical department, and here we had working. So here we had more than 80 presentations, except the few hiccups what we had today morning, but otherwise it went smoothly. It indicates for us the hybrid mode what we the presentation what we started at in RCRM port, it is possible, except the some minor issue can come from because of network issue at the participants end, but otherwise we didn't have a much problems here. So that what is quite encouraging, and looking your face, I can see that you also have a tiredness because of 2.5 days we put a lot of because tiredness is a good for us, because that what indicates that we really put up not a lot of knowledge, not a lot of new ideas, and that's what is makes you the tiredness. No doubt in your back end of my back end, there are a lot of my PhD scholars and the MTech scholar and the CET staff. They really work hard to make it this. I can, from my side, it's a really successful conference. Organizing 80 presentations, the 55, 56 presenters from TIH side. So we did a marvelous work within a few days preparations. We can do these things. So with this, I just want to thank all of my group as well as TIH to support these projects and all this. Thank you.
Now I would like to invite our head of the Center for Sustainable Water Research, Professor Suresh Katha sir, to share a few words to our participants.
So very good afternoon to all. So this 3 days program, what Professor Datta has already explained to you, this river corridor management research, this particular conference is being going on for last few years, and this year it has been conducted in a hybrid mode. And IIT Guwahati has established this particular center called Center for Sustainable Water Research, considering the need of the society as well as the region here. Northeast is abundant of water resources and all. So highlighting those aspects, this particular center has been established to take care of high-end research as well as taking care of many of the project activities that are required to establish studies and all. So that way this center has been established in 2022, and now under the belt of this particular Center for Sustainable Water Research, this year's RCRM conference is also being held here. I am happy that all of you have physically participated here, and really thankful that you all have given your dedicated time, energy and all to present this thing. So our distinguished guests even from Japan also, they have given keynote lectures. We have Professor Panda from Georgia Tech, and yesterday Professor Tirupati Bolisetti also gave good lecture. So there were some very wonderful inspiring lectures which I am sure that you can take note of and you can progress your career from there. So with that, I wish all of you, and also I thank all of you to actively participate, in actively participating this particular conference and all. Thank you.
Thank you, sir. Now I would like to invite Professor S. Ravi sir, our Dean of Faculty Affairs, IIT Guwahati, to share a few words to participants.
Yeah, very good afternoon to all of you. So dignitaries on dais and invited speaker and participants and faculty colleagues and student everyone. So congratulate you for the successful meeting of river corridor research. This is one of the relevant topic research in this area. So we also a lot of erosions we come across. People from IIT help the local state government in rectifying some of them. So having the meeting of such a wonderful topic is going to really help and evolve a method, mechanism and whatever technical support our team probably would have got. I hope you enjoyed the campus here, and is one of the good campus, I say that, within the country. And a few word about our institute. So other than the initial few IITs established in the country, so this which was initially established with the help of some of the foreign countries. This was the first institute established, first IIT I would say, established with 100% funding from the government of India. Later there are many more IITs, new IITs joined the group. And I also want to say that our institute, as far as the National Engineering College ranking is concerned within India, so we stand 7th within India. And as far as the ranking of in the globally ranking of universities, engineering universities, within the 50 years of age, we come under the 100, within 100 rank. So that is good for this age. And if you just look at the class of within the what the citation of the papers published by each faculty, we have some 32nd rank. So some of the era we excel, but still a lot of work more to do. So with such interactions, probably we would your team and you will have collaborations is going to help much for the betterment of the institutions and people in this region. So thank you all for listening.
Thank you, sir. Now I would like to invite our head of the Center for Intelligent Cyber Physical Systems, Professor Kanagraj sir, to share a few words.
Good afternoon, everyone. And first of all, I would like to congratulate the team for organizing a wonderful conference. Okay, and thanking you for all the participants and the keynote lectures and all. As being the Center for Intelligent Cyber Physical System, I will tell a few words about our center. It started in 2020, and we are offering a MTech program in robotics and artificial intelligence, and it is a 20 students will be from MHRD, a Ministry of Education Fellowship, and 20 students will be sponsored from the industry and other sponsored agencies. Okay, so we are also offering a PhD program. So if and it is an interdisciplinary center, and we have a collaboration with the civil engineering, mechanical engineering, design, electrical, electronics, computer science. So if anyone is interested, you please welcome. Okay, so with that, I would like to thank you very much.
Thank you, sir. Now I would like to invite Professor Sudhanshu Panda, sir, to distribute the certificates to our faculty members of TIH during the because this 3-day event had also a component from the TIH also. So we had the presenters from the faculty sides also. So I would like to request Professor Panda, sir, to come forward and distribute the certificates. So Professor P.M. Pathak, sir. Professor P.M. Pathak, sir. Professor Pravas Ranjan Sahu, sir. Professor P.S. Robi, sir. Professor S. Kanagraj, sir. Dr. Saurav Suman, sir. Dr. Sahdev Roy, sir. Dr. Barun Pratihar, sir. Dr. Poonam Kumari, ma'am. Dr. Rishikesh Dilip Kulkarni, sir. Dr. Biranchi Panda, sir. Thank you, Professor Panda, sir. Now I would like to request Professor Subhashi Datta, sir, to distribute the certificates to the TIH project staffs. Dhanush Devappa, BC. Kalyani Pawar. Nitesh Kumar. Abhimanyu Singh. Kagita Nagakonda Bhagyashri. भास्कर ज्योति तालुकदार. सत्यव्रता साहू. सूर्य प्रकाश मिश्रा. रौनक मोहंती. अभिजीत महापात्रो. Okay, thank you, sir. So now I would like to announce the best presenters of RCRM Conference 2024. We had in total 12 themes. So we would like to announce the participants who have won the best presenter awards in their respective themes. Yes.
Hello. I think this is the moment what almost all the participants are waiting for that. Even if you have an online or offline modes, okay, the best presentation awards always matters, okay. So the first one, okay, next slides.
Sir, we will provide e-certificates. We will provide e-certificates.
Regarding the RCRM participants, so we are going to provide you the participation certificates. Within the week, we are going to send it to you. But as we are busy with our all these schedulings and the presentations, so we will mail you the e-participant certificate shortly. So in plot modelings and plot monitorings, so I think Akshay Kundu, I think from IT Mumbai, yeah. Numerical and physical modeling for rivers, it goes to the Dhanesh Bros, I think, again from IT Mumbai, okay, the energy minimum concept. River morphologies, it goes to Dhansri Rivers, Sanku Ghosh, whether he is here? No, okay. Geospatial technology for river basin management, next. Okay, it goes to the Priyanka of Praveen Patel, and climate change studies, it has gone to the, I think he is here. Yes, please have a big clap for him, which is, yeah. Yeah. Yes. Yeah. I missed it. We'll edit that things. Play. Next. Okay, this is from Japanese group, so whether she is here? Oh, yeah, please come. Please come. Please come here. So it's a quite interesting topic of human and flood interactions. So you will also edit your photo for certificates only. Thanks. It goes to Adbhiya Halal Shah. I think he's from. Okay. Wetland restorations programs. Okay. Kabyasri Chaudhary, she is here, I think. Okay. Next. Okay. Padmi Samal, I think she's in online modes. Okay. Thank you all for this. Really have a 9
Yes,
themes
sir.
now.
Thank you.
Thank you.
Thank you, sir.
Actually, from TI side, everyone presented nicely. So, all are the best. Put their best effort.
Now I would request Professor Sudhanshu Panda sir to share a few words.
Hello. I'm really honored to be here, and this conference, 2.5 days, or you can call it 3 days if you add up hours, it was amazing really. And as we know, water is white gold. Really, the gold doesn't matter anymore. Water matters a lot, and all of us, even the TIH group, everybody is working with water. So all the studies we are seeing here, it is really precious like white gold. And one more thing, Dr. Polisetti told briefly, if you really listen to it or take it to the heart, that is actually one country declared the river as a person. That is New Zealand. So it personifies the river. Means river can challenge anything bad you do to the river, then river can go to the court. So for river, there is a team already there. They can really fight for the river as a person in court. So that means we need to understand what the importance of river in our life. And New Zealand is really a kind of leading us, showing us the path. And here we pray, actually Ganga Yamuna is like goddess. We do not give a damn about her at all. Just by namesake or just saying she is God. But we do whatever all kind of bad things to the river. So that is not really right. And all of us scientists should have a goal. We need to teach, find a way to interact with stakeholders like everybody who deals with river, bad way or good way, to do something good for water and work on it. That's our, should be the motto as a scientist. Our motto is not to publish paper or just present here and go home and be happy, oh, I did so crazy good things. So we need to have our work reach ground level. So that should be a must, and we must really seriously think about it. And almost all presentation, few guys from every session got selected as a best presenter, but every presentation I saw, I got the luxury to see. I could not go to the other one, but here I have seen every presentation, all are really tremendous quality. But my one suggestion to every presenter, every scientist, if we bring in the field aspect to our research, not dwelling on too much software based analysis, it would be really crazy good. Seriously. Anything, any research we are presenting or showing, we should have a practical aspect of it, and we need to include stakeholders with it, how we can bring our analytical result and in a helpful manner for the people outside, and they get helped, then our research will be fruitful. But to be honest, it is really so many conferences I have gone, but this one of the best one, well managed, really. Well, and I'll be coming back, and next time I'm expecting we will have more papers which has in situ and field application. So, and it will be really very, very good. And what else I need to say? Very well managed, and we all enjoyed. I don't think any single group here didn't like what we did here. And online, offline, everybody really appreciated what scientific development we are doing and presenting to scientific community. I'm taking home a tons of stuff. One single thing I can pinpoint. I asked Dr. Dwivedi after his presentation, we are working on a research. That was a 3-day workshop, and entire 3-day got divested into one single issue. They forgot about everything that was in the agenda. Like it started in the early Army Corps of Engineers and your Department of Fish and Wildlife and DNR. Everybody discussed on a single issue. The fish, hatchlings are dying just like that with the decrease of 1 degree Fahrenheit temperature in the stream. Why? Then mechanical engineers, civil engineers, everybody come up with ideas, and we discuss. We could not figure out how. And my idea was because the hatchery is just below the sluice gate, why not we push the water with high velocity, just reducing the gate size. Some of come up with the idea, crazy idea, we'll have a big fan in the river so that we can put heat and just make it temperature rise. So my point to take it, if we do brainstorm, we will be really coming up with great ideas. Single person cannot do brainstorm. Dr. Dwivedi immediately answered me, maybe the ammonia could be creating trouble. And I talked to another person, he told, yes, because it freezes. Ammonia, if more, then the water got frozen and 1 degree or 2 degree temperature immediately go down. Then we watershed modelers can find out if more ammonia is going from the watershed to the water body and reducing the temperature. So if we talk to each other, and in the beginning of the session, I think the director was talking about work as a group. So we must work as a group. And Dr. Datta has showed already, like having this conference, international conference planned, and bringing in a lot of people into it and making it a success. So we must follow that concept. Please do not do research on your own alone. All the PhD students working on single teacher, everybody talk to each other. And even other teachers group, maybe time to time have some kind of discussion. That way things will grow. And this conference for me is one of the biggest successful conference. So I'll stop here. Thank you all, guys.
Thank you, Professor Panda sir. Now I would like to request Professor S.K. Dwivedi sir to share a few words to our participants and audiences.
Yeah, so now I request our participants from PAs who can tell you what's their experience and other also. So I request Professor Dikit to tell a few words.
No, it has already been said that conference is a great success, and I am happy that our guests who have come, they are happy. And I also saw some presentations. Participants are very enthusiastic and they presented. And one good feature of this conference has been that not only the civil engineers, but mechanical, electronics and everybody. So perhaps it is the first such conference, it is 4th conference, but in such type of gathering, diverse gathering was not in any conference. So parallel sessions were going on from TIS side, and TIS side contains 3 people from various disciplines, design, mechanical engineering, electronics. So in that sense, this is very great, and as Panda sir has already told that we have to do joint work, collaborative work, this is the age. So, and he has rightly pointed out that in our country that personification of river was already there. We say Mata, no? River is Ganga Mata and other things. So that type of spirit should be revived again, and we should work for the welfare of our country and in fact our world. We believe in Vasudhaiva Kutumbakam. That means whole world is our family and we have to protect the rivers. Oh, thank you.
Anyone else want to tell something?
Anyone else? So we have Hayashi sir also from Japan. I request to share few experience and words about this conference.
Oh, in this time, thank you very much. I'm so happy to join the this river corridor research and management conferences. Fortunately, we have Professor Terao and our research group is continue our activities in this Assam area together with IIT Guwahati support. I think I'm becoming older, so and it is very difficult to come here frequently. But the young generation of Terao-san and Kaimura-san and Kiguchi-san and the newcomer of our research group is Marina-san. So our group will continue in future our research. So and please support us. Thank you very much.
I would also like to request Professor Toru Terao sir, who has also came a long way from Japan. He has also chaired one technical session of the participant and also given the keynote lecture to all our participants in this conference. Sir, please.
Thank you very much. So I'm very happy to be here, so sharing this very great time with you. And so we are basically somewhat come from different area of the globe. And also scientifically we are basically meteorology and some hydrology also there, but the meteorological background is there. But we feel that almost all issues are very same. So sometimes it is disaster, sometimes it is a environmental change. So different perspectives coming to that same problems as we are solving are very important issues in the globe. And also we feel very, なんていうかな、friendly environment is here. And so every time we taking tea and also taking some lunch or dinner, we are so much enjoying with you so much. So thank you very much for coming here with us. And we are so happy. And we will come again and again. He will also coming again and again. So we are all so good team. So we will be happy here. Thank you very much. And also, and all that the people are having this, managing this the big conference, it's very tough. So, but we are so much smoothly coming and we can join here. So thank you very much again. Thank you.
Thank you, sir. So any other questions from the participants' side? Okay. So now we are towards ending of our conference, this RCRM 2024. So the last vote of thanks, I think Professor Subhashi Datta sir will deliver. And with this, we will be ending with our... Okay, sorry, Professor S.K. Dwivedi sir will deliver the vote of thanks for this RCRM 2024. Hello, Vinay sir, Dr. Vinay Chembulu sir from IIT Jammu. He was the conference co-convener from IIT Jammu side.
Yeah.
Sir, I would like to request you to deliver the vote of thanks. Hello. Hello, sir, Vinay sir, can you hear us? Sir, you are not audible to us. Sir, please. Okay. So, okay, so with this, I thank you all. And I would like to request Professor S.K. Dwivedi sir to share the vote of thanks and conclude the valedictory session of RCRM 2024.
Okay, so thank you everyone. So now we are going to conclude this session. So let me thank Professor Ponda and all the dignitaries from Japan, and also many of the faculty members from different IITs. So actually from 12 IITs faculty members are here, and from another 10 NITs faculty members and staff members are also here. So I welcome and then say goodbye to all of you again. So now we are coming to the end of this session. So particularly let me thank our postdoctoral fellows who have continuously worked hard. Actually I have not given any time this time, so they have actually managed all the things and all the sessions they have managed. Also I sincerely thank all the chairmen of all the sessions, so they have contributed a lot. So let me thank also the participants, those who have come from long way from different parts of our country, and I hope all of you enjoyed the stay here. So with this thing, let me thank everyone, and let us meet again in this RCM. So where it will be? Next time in Jammu. Yeah. So I welcome all of you to join the next RCM in Jammu. Thank you everyone. Now.
So with this, we conclude the marathons RCRM 2024. Thank you.
Group photo? Any group photo?
Okay, we'll have a photo. So final photo.
We will have a group photo. Outside. Okay, we will have Professor Dean Affairs. So all, please come forward. Please come forward. We will have a group photo. उसके पीछे भी Please, all of you come forward, please. We'll have a group photo. And after this, we will be going for a lunch.